All right, let's see. Hello, everybody. Hello. The few of you who are already here. I never know whether to start the stream. Like, do I announce that I'm doing the stream before I start the stream, or do I announce as I start the stream? But then people are going to miss the start. But then when it's a VOD on YouTube, if you're watching this in VOD form, you probably want the start to be interesting. So, I don't know how to balance these two things. But, hello, everybody. Because if it's a YouTube video, I need to like immediately start doing stuff. Otherwise, most of you are gone already by now. But if it's a stream, people are kind of just chilling in the background. Oh shit, I don't think I even set up my windows. Jeez. Jeez, hold on. Okay, I got Unity. I got some kind of browser window going. Should probably do that. And then that. Wait, where's my... Oh, there it is. Okay. Zoop, zoop. Okay, and then I'm gonna put... There we go. I guess you can just use chapters. Yeah, I suppose. I think YouTube also allows you to cut away certain sections of the video, so I could just remove the intro setup stuff. But then I've had people say like, "Oh no, I want that to stay in the video," and I'm like, "Oh, that seems weird." But anyway, so tonight, we're hopefully going to implement the bevels, because we've been working a lot with basically trying to optimize the tessellation or the topology, both, of the cap meshes on triangles. And this is specifically for bevels, which is a little bit esoteric. So let me just show you what I mean, because we're kind of several layers deep into this. So I'm making a 3D modeling tool. So it's kind of like Blender, but not Blender. And one of the tools that people generally like to have when doing 3D modeling is something called a bevel function. So a bevel function is basically when you have an edge, sometimes other shapes, but an edge is a simple case, and you want to make it smooth, or you want to like flatten it somehow. You want to like chisel down that edge a little bit. And so that is looking like this right now in half edge. So basically rounding an edge. And that's straightforward enough when you have a simple shape like this. But the moment you start doing a lot more intricate situations, like I don't know, like a shape like this, and you want to bevel all three of these, then the way that these should be shaped gets a lot more complicated. You know what? Let's pull this one too, just to make, and this one. There we go. Just to make life a little bit weirder. Then the way that you should define this corner gets a little bit more complicated. Because you're not using 90-degree angles anymore, and you have multiple edges coming in. And so when you have 3 or more edges meeting at a vertex like this, and you bevel, you need to create a cap. You need to fill a hole, effectively. And right now I got an error, so we can't quite see everything here. But you can sort of see the topology, where you would create a rounded bevel here, a rounded bevel here, and a rounded bevel here. But then you need to make all of these faces meet in some kind of shape, in some kind of nice way, right? That is the part that I'm working on right now. This, specifically the cap filling of bevels. And this is a relatively non-trivial problem, and there's a lot of ways you can do it badly, or in ways that is fine, but not very good. And so one of the things I've been working on of late is to try and figure out a way to do this where the, so there's kind of two things happening. One of them is that generally 3D artists like using quads in the workflow when creating meshes. Quads are nice for many reasons when creating meshes. So a quad is just a face with 4 edges and 4 vertices. And so when we create this cap around the corner of a bevel, generally I want to try to stick to quads as much as possible. And so it's kind of this process of, given n number of subdivisions along an edge, find a quadrangulation of that whole shape. So quadrangulation is just triangulation, but with quads instead of triangles. So basically divide it up into quads. And so that's sort of what we've been doing these past few streams. And so a lot of this is pretty much solved. You can change the number of subdivisions along the edges. There will be a triangle in the middle, which is expected because it's kind of impossible to find a like a symmetric solution that doesn't involve a triangle here. But for even numbers of subdivisions, there's always going to be quads only. And so last stream we added support for arbitrary side counts. So now it's not just triangles, but now we can have pentagons or hexagons or heptagons or whatever n-gon you want. And then the tessellation is separate from that. And on top of that, if we go back to the triangle case, there's certain ways you can set up the coordinates inside of this triangle to make it look a little bit less jagged, because usually you want it to kind of join all the 3 different incoming edges in a smooth way, but the kind of naive way of setting up these coordinates, you kind of have these very straight lines, and then they suddenly change direction, and then they suddenly change again. And these kinds of straight lines, or rather, these kind of sudden changes are going to kind of show up and look weird in the actual use case when we put them on a corner. And so one of the things we've been working on is making this smoother. And by smoother, there are many different ways we can interpret that. There are many different types of smoothness we could care about or talk about or optimize for. So what we did last stream, or a few streams ago as well, for the past 2 streams, I forget, is setting up a system that can kind of solve this for certain properties. So one of those properties is area. So all of these faces here are color-coded. So blue means that the area is bigger than the average, and red means that it's smaller than the average. And so we set up an algorithm we wrote code to basically solve this for area. And if I just solve for area here, you can probably see how it's changing here. So now I'm doing no optimization, and then here's the iterative optimization, trying to optimize for area. So what it's doing is effectively adding forces to every vertex in order to try and make every face have the same area. And you can see that it's doing a pretty good job. Like you don't really see these colors anymore. They fade away, which means that they don't have, which means they're very close to the average face area now. So now the color is pretty much gone. It's a little bit of a blue tint in these corners. So these are slightly too big still. But I think I can just let the solver run for a little bit more, and now it's stabilized. So now every single face has the same area as every other face. But this is obviously a really bad tessellation because this is so wobbly, and we kind of didn't really solve the original problem of having, jagged edges. I forgot to breathe. So let me just breathe and have some water. Long yap. Trying to summarize, because there's a lot to summarize. Whenever we're super deep into this, and someone comes into chat and they're like, oh, well, what's Freya working on right now? And I'm like, oh, geez, we're going to have to back up very far. Okay, so just optimizing for area gives a, it does optimize for area, but now the angles, the internal angles of every vertex is obviously very inconsistent and very wobbly. So these little discs here, they represent an internal angle discrepancy. So red means that the angle is too small, blue means that the angle is too big, and when it looks like it's pretty much gone, the angle is the correct angle. And so what we can do, let me just reduce the force multiplier a little bit. So what we can do is we can optimize for area, or sorry, optimize for internal angles as well. Very, very similar process. The system basically adds forces trying to make all angles the correct angle. And so if we start optimizing for angle, you can see that it immediately starts looking a lot smoother. So it's taking this shape from the area optimized one and then twisting everything into place. And now you can see that the lines here are much smoother and they look much more pleasant, right? And comparing that to what we started out with, you can see that there's bigger color differences. So the area is there's a huge difference in area. And we have these like very straight lines and then suddenly changing. You can see it especially here. A straight line, sudden change, straight line. But as soon as we start optimizing for angles and area, it goes from being pretty straight and jagged to smooth, like this. So now we have this kind of a nice curve going from, twisting the camera? Going from here to here, instead of like this very harsh, linear looking thing. And so that's kind of cool. So now we have like a better distribution of these. Another thing you can optimize for is, I was going to say edge length, but it's not really edge length. It's more equilateralness, equilaterality, equilateral, whatever that word would be. Basically trying to make each edge of every face have the same length as the other edges. So that means that it would try to distribute the total perimeter evenly across all 4 edges. So there's no assumption about a canonical correct edge length. It's just trying to distribute it evenly in each face. So if we optimize for that, we can see that it's shrinking towards the center again. So now if we do if we set edge length optimization to 1, then we're kind of back to where we started, which is not good, right? Because now we have these like very linear edges and then sudden changes again. But in practice, I did notice that having a little bit of edge length optimization, one important thing that it does is that if you look at these edges, ideally, we want these edges to point toward the opposite vertex. Because that makes them more aligned with, the actual edge coming out of here. Because remember, this is the corner of a bevel. And we want this to be aligned with whatever's going out here, and whatever's going out here, and whatever's going out here. And I noticed that adding the edge length optimization twists these to point towards the opposite vertex, which looks a lot better. And because we don't have that, we do get this weird effect where the outermost section does have pretty harsh changes abruptly here. At the very first loop inside of here. Like there's kind of an abrupt change there. And optimizing for edge length kind of smooths that out a little bit and it makes them point toward the opposite vertex. But this is, of course, in direct conflict with area, because as soon as we start doing that, the area discrepancy increases. So it's kind of a big balancing act of trying to find kind of that sweet spot where you're optimizing for the things you care about, right? Yeah. So that is what we've been doing on stream. And of course it works on all of the other shapes as well. All right. So I'm thinking I should try and get these implemented, or at the very least, like clean up the code. And I should clean up the code because it's very much a mess right now, and try and figure out if I want to set up like a caching system for this, or if I should try to make it real time. I'm not entirely sure what I'm gonna do, but it requires, I do need a refactor and a cleanup regardless. And yes, I did have a bunch of issues last stream where I refactored the code and made a typo. There was like one place for the internal angles, and also the order for the central n-gon was in the opposite direction. So there were a few things that were wrong, and so I fixed those off stream so that it now works the way that it's supposed to. But yeah, so that is what this is. I guess I should probably remember these edge weights. Yeah, I'm not entirely sure like how much I should prioritize all of these different properties. I guess I'm probably going to change them over time. Once I see them in the actual use case, it's probably going to be different depending on yeah, it's going to be different like when it looks a certain way, or when it's in 3D. Is the optimal area the same size everywhere inside the shape? For every quad, yes. Every quad is trying to optimize for the average quad area, yeah. So basically the area of the n-gon minus the area of the central face, if there is a central face. If there's no central face, like this, then they're all optimizing for the same area. I am not making snowflakes, but you can make snowflakes. All you need to do is to crank the angle optimization a little bit too high, and then the solver gets very nervous and explodes into various snowflakes. Are planning to update the project to Unity 6.3? Probably, yeah. I don't think I have a need for any new features, but I'm generally trying to stay up to date on half-edge. Or how so? Is there something about 6.3 that I should know about? Did they change the monetization or something? If there's no central node, couldn't you add a central node and create additional faces? Yes. But the system that I wrote for this is probably going to be relatively left to its own. And then I'm going to do the central phase separately, is my plan. Yeah. I am going to have to try and figure out... I am going to try to figure out the spline part of this. I could probably ignore it for now and kind of like set up the infrastructure and refactoring it and cleaning this up so that I can actually use it, and then I can do the like spline part later, because this is basically the topology part, or most of it except for the central cap. And once I have that implemented, I think the positioning of the vertices is kind of the easier part, I think. Or it's not easy, but it's going to be somewhat reasonable. If the flat mesh gets inflated to fit a curved surface, won't the quads near the middle end up getting stretched larger than the ones near the sides? Yes, probably. At least for the triangle case. Yeah. Oh yeah, someone asked about the n equals 4 case. Yes, the n equals 4 just looks perfect. There's like, you don't see any internal angles, there's no face coloring or anything, because like it's literally just a square. It's very straightforward. There's no, this is the least complicated case. This one is fully optimized for area, edge length, and angles. All of them are perfect, so. You could add an additional constraint that minimizes the distance of each cap loop to the spline constructed by the tessellated incoming edges. So I want to try and get away with not having to run the optimization every time you bevel. It would be nice if I don't have to run that code and get like a good enough version first. I think there's like, because the moment I make it specialized depending on the 3D geometry, I can, yeah, sure, I can make it be optimized better for that current situation, but then I have to do that optimization real time. And I don't want that to bog down the user experience because it might slow things down. I might have to write a bunch of code to make that run faster and that kind of stuff. So right now, I don't think it's a priority. I just want to get this, get my current version implemented soon because I've already spent a lot of time on this, so. Are all the optimizations local to each quad, or are there dependencies across quads? They are all independent. Yeah, they're each optimization is iterating through each face, and then each face adds forces to the surrounding vertices, and those forces are kind of summed up, and then that's the final force on each vertex. Oh yeah, there was a yeah, I guess I only really know what it should be for a triangle, but the thing about these edges pointing towards the opposite vertex, right now I don't actually optimize for that. Like right now, this one is trying to optimize to have the internal angles be 90 degrees, but that's kind of the wrong target for these edges in particular. And so I'm considering like making these actually try to optimize for the angles that point towards the opposite. But I feel like it's probably like good enough right now anyway, and the edge length optimization sort of did that move regardless. I have a transcendental question. Damn, okay. Why in this project, and specifically for this case with fillets, you prefer to use mesh instead of NURB surface? Don't you think it could be easier? I mean, they're different things that are used for different purposes. So half edge is going to primarily be a polygonal modeling tool. I might add stuff like sub-D meshes down the line, like full-on manual NURBs or like CAD style modeling is just not really what half edge is supposed to be. Half edge is designed for game developers, and so CAD is not the priority for half edge. But I might add stuff like that down the line, and I will be using splines and surface patches to, I'm already using like Bezier patches to actually create the shape of these caps. I should have it somewhere here among my tests. Yeah, like this one, for example. So this is a spline patch, or you could call this a special case of a NURBS surface as well. But yeah, so this is what I'm using right now for specifically the 3 incoming edges. Yeah, okay. Let me just quickly bring up my notes and make sure I don't show something I'm not supposed to show on screen. Do you stop before the number of iterations is done? I don't have any heuristics right now for like a stopping condition. Right now, I just have a slider that specifies the number of iterations, and then that's that. Havage, let's see. Task notes. I'm not prioritizing non-destructive workflows for now, because that is a huge rabbit hole, and I haven't thought of a design for that feels great right now. Like whether I should go for geometry nodes or a modifier stack or like a post-processing thing. I'm mostly leaning towards a post-processing stack, like you would have a polygonal model and then you have post-processing on top of that that does stuff like subds or bevels. But modifier stacks have a lot of issues, and like geometry node stuff also has a lot of issues. Especially, and there's a lot of work to add those things, especially the node-based stuff. And so it's a lot. And I think for 1.0, I'm probably not gonna do stuff like that. Maybe at most some kind of subd modifier, but okay. Did I have notes for my bevels? I don't think so. Okay, I guess I'll make a new note. Bevels. Thanks for your game time math videos. Thank you. I'm happy they were useful while doing math. Okay. There we go. Sorry, I just had to make sure that I had notes open for this. I watched some of your videos, loved it, but this live stream goes above from my hand, or above your head, or yeah, I mean, this is kind of in the middle of all my work on this, so it's not designed to be like a tutorial at all, or like a pedagogical video or something. Okay, what do we have to do? So there is the question of caching the optimized variants. It's kind of low priority. I guess I should do a... okay, so basically we're doing cap meshes for bevels. And we need to do the three-way intersection. We need to do the four-way intersection. And then we need to do the n-way intersection. Oh, and also the two-way intersection. Okay. Okay, so I need to refactor, clean up the code, because right now it's a mess. And I'm also gonna have to add the like the UI controls for, because right now you can't set the like subdivision amount or anything. It's all like, that's hard-coded right now. So I do need some UI for setting subdivision count. Actually, there's going to be a lot on the UI. There's going to be subdivision count, bevel, bevel type. Is there anything else? Oh, thank you so much for the dono, Alpha Rock. Thank you for all of your work educating the masses on tech art. Your Shada videos re-engaged me after years. After I lost interest from boring grad school graphics classes. Oh no. That's cool. I'm glad my videos have been helpful. So bevel type, I suppose. What are the different types? There's There's like round, and then there's a flat bevel, but that's just the subdivision count, so we don't really need that. But we do need the size, or radius, I suppose. There could sort of be a bevel type down the line, because you can sort of do edge distance bevels or a spherical radius. But this one is hard. This one is easy. So I'm only doing this one right now. But I suppose I can maybe look at that down the line. And then there's the profile curvature. As in, there's that on top of these, or there's, or do you mean like one of these this is known as the profile curvature? Or do you mean like custom profiles where you like specify the shape explicitly? Okay, so I think this is a pretty good little task list. Okay, I need a drink because I'm thirsty. I should have water, actually. And so thank you, Simon. Okay. 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 I guess we will just start cleaning up the code. Yeah, I just need to open the code because I don't remember exactly how bad it was. Blender's bevel modifier, for example, has a radius and a scalar profile parameter that interpolates between fully 45 degree and fully not beveled. What's fully not beveled? And what's fully 45 degree, actually? Okay, let's see. Why are all of these showing up as yellow? Oh, because it's still loading. That's probably why. Like a squircle profile? Like that kind of thing. Okay, right. Yeah, guess I could do that kind of stuff. Oh, Salad just sneezed, and I just got cat sneeze on my hand. Thanks, Salad. Thank you. Where are we? Can probably squeeze something in here. Right, so you're basically talking about like if you have a corner type of deal, you can have a very like sharp one like that, or you can have a very like standard sort of circular arc, I suppose. That's a little bit more roundy. Which I guess would mostly be a matter of like setting the tangent lengths for the spline. It's pretty useful when you only have one subdivision to sharpen or dull the edge. But if it's only one subdivision, we might be using the word subdivision differently. When you say one subdivision, do you mean it's got two segments? One vertex inside the bevel, right, okay. Right. I can sort of see that, yeah. I think that would be relatively easy to parameterize, yeah. 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 Guess I can add that. I don't know what to call it, sharpness. Or maybe smoothness? Roundness? But yeah, anyway. There's kind of like the bevel type thing is basically where if you do a profile view again, and imagine you want to like bevel this by making, you know, smoothing this corner. There's kind of two different ways of doing it. So one of them, let me actually draw a shape like this. Okay, so we're going to do two different types of bevels. So one of them, we're going to pick a, basically a kind of like a radius of this distance right here. And that's going to be the same like a radius for both of them. So this is the edge you selected. This is a side view. There's an edge going into the distance here. And then you basically create a smooth connection between those 2 points. So you would basically do the same thing here. You would find a radius here, and it would be the same as for the other one. And then you would smoothly connect those two. So this is kind of like the heuristic here is that you specify the distance to the edge that you have selected, or the edges that you've selected in your bevel. This one is the easy one. Because it has way fewer edge cases than an alternative version, where instead of specifying the distance from the original bevel, you specify the radius of a circle that you try to fit into every corner. So I guess I should overlap the edges. So in this case, let me give this a different color just to differentiate between these. So now you specify basically the radius to the faces of the bevel here. It's not perfect, but hopefully you get what I mean here. So now the radius is the radius of this circle you fit in here. And the thing that makes this case more complicated, okay, there should be more symmetry here, but pretend it's symmetric. So as you can see, the connection here makes for a pretty small little arc between these, right? But for this one, the arc between these 2 points is much longer. And this method is probably like, it feels very intuitive, but it gets less and less intuitive the more dimensions you have. It sort of works okay in 3D, but as soon as you have more than 3 faces that meet at a vertex, it gets weird. Actually, even just 3 has a few weird edge cases where you kind of have situations where things just don't line up. But when you use the edge distance variant like this one, it kind of always works. Like this is very reliable. But this one is has a lot of edge cases. It's messy. What if radius is larger than edge length? Then it's over. Then you are simply you are simply done. Yeah, that's kind of an issue, like regardless of which method I use. And I mean, there's many different ways of handling it. Like I could check for the maximum available space and then clamp whatever the user tries to do. I could just let the user make weird geometry and then they have to clean it up and leave it up to the user. I don't think it's a big issue. I think I could go either way on that one. Like sometimes there's an advantage of letting users do invalid geometry, because you might have invalid geometry as an intermediate state. Like you want to do a bevel of a certain size that's theoretically impossible, but after you've created it, you want to then modify the geometry to fix it up. And that fixing it up part, I can't make those assumptions about what you intend to do as a user. And it would also be a lot of code that might be very difficult to write, so. Okay. So, I'm going to clean up the bevel code. There's also specifying distance as a percentage or relative distance, which is calculated for each edge instead of a constant. As a percentage. Percentage of what? The distance to the other side of the face? But like that's gonna vary across the edge, or what's the measuring stick? Okay, I am not sitting comfortably. My back's gonna hurt if I sit like this. Okay. Gotta get comfortable. And now chat is not visible. Come on, chat. There you go. Blender has that option. Always works, but rarely well. Makes different size bevels at different parts of the mesh. But based on... Is it based on like the maximum possible size? Oh, like along the edge? Like the other edges, I guess? I can't think of a single use case for that. That seems like a really weird... Seems like a weird one. Unless you're like using bevels for something that's like inherently not for visual meshes. Like maybe you're doing it for like topological stuff or for some tech art reasons, or I don't know. But for like visual meshes, I don't know. But maybe there is a use case. Okay. So let's see. Where is all of my stuff? So calculate forces. That's the solver. Oh yeah, quadish and gone. Now I remember. Now I remember. Cool. Okay. So I think I'm actually gonna make some notes here for my code structure. Contains. What does it contain? This is the tessellation. Yeah, this is the tessellation traversal structure. Yeah, but no optimization stuff. Cool. That is good to know. Hello. Wait, Sophia. We'll fray it. Right. Welcome back. Okay, quadrangulation is that. Got a bunch of irrelevant stuff. Ngon topology test. Oh yeah, this was just testing the thing. Okay. Okay, I guess all of the iteration stuff is actually in this this one test script, which is not not super ideal. But we don't actually have to implement the relax stuff yet. So I'm actually going to set that up as a separate thing. So it's kind of like implementing the quadish ngon in practice, and then there's a separate thing of implementing the optimized. I can't call it tessellation because tessellation is like topological, but the optimization we did, what do I call it? The optimized distribution is a better term. It's like a distribution of vertices, effectively. Which, and caching of those is kind of like an optional side quest. So four-way intersections require requires the bilinear patch. So I guess it will be a bilinear cubic spline, or Bezier probably easiest. Okay. So let's go to Beveler. Oh boy, this is the weird hydra that kind of grew out of itself. I really need to refactor this because this turned into a weird, really weird structure. At some stage you want to implement a UV buffer. What do you mean? Okay, let's see. What's the agenda today? Today, well, this is the to-do list I have. I'm not super aspirational about trying to get everything done today. Probably not the UI. But I do want to try to implement the actual code that we did for the generalized tessellation. And then I want to make the three-way and the two-way intersections work. That's what we're gonna do. Okay, why is... Oh yeah, okay, so create junctions is just setting up the prerequisite stuff. But like, why is the... I feel like I'm just creating this object and then calling apply bevel immediately. Yeah, exactly. Okay, this feels kind of unnecessary. I feel like it should just apply immediately, and split and inset is not what this is doing. Okay, let's see. So we are getting the edges, passing it into here. Does the beveling work for any amount of edges or just 3 currently? Well, It works for, well, it depends on what you mean by works. It doesn't explode, but it's doing the prerequisite topological stuff of figuring out what to do with it, and it creates the holes for where to put the beveled edges or the beveled faces. But the filling of the corner is pretty much only set up for 2 or 3 faces right now, or edges. But even that's not working because I broke the code, because I've kind of been refactoring this left and right. Or not refactoring, breaking it left and right. Okay, so this is dumb. I'm just not gonna. Well, why do I even have a separate function for that? We're gonna remove that. And I feel like we don't need to do apply bevel. That feels kind of pointless. So these are our edges, and then this is going to be a parameter later, but right now it's hard-coded. So that's the inset distance. And I guess we'll just create a beveler. So instead of just create junctions, that's instead going to be part of applying the bevel. Or no, I know why I had this separated. Never mind. Never mind. Okay, yeah, apply is going to be separate. The reason they're separated is because this beveler only has to be created once for every selection. But when you drag the slider for the number of subdivisions, I can reuse the same data in the beveler. That's why I separated the constructor from the apply bevel function, because we do actually cache data here. That's useful. Which is also why I feel like subdivision count and bevel mode should not be in the constructor. That should be in the apply bevel function, because that's the thing that might change. Oh, same thing with bevel distance, actually. So we're going to move that as well. Bevel distance, that's a weird name. We're going to call it inset distance, like I did in the other one. I'm new to shader creation. I really admire your skills. Thank you. What would you recommend as a starting point for someone like me? I mean, I would recommend my series on shader coding. But if you've already seen that, then I'm not 100% sure. I'm pretty bad at remembering places. I'm pretty bad at remembering places that have good like shader resources, because I don't really consume that myself, so I'm not sure what's out there. I assume that was one of the final goals. A competent game editor with UV editing. Displaying the UV data flat next to the mesh is a common layout. Yes, I'm going to make a UV editor. Yes. That's actually one of the things I'm looking forward to the most. Okay, we don't need a function for this. Okay, so this is per selection. Right, because we passed the bevel edges in. Wait, why does this... What? Oh, this one takes a hash set. Okay, well we can... Wait, how did I... It is a hash set. Right. I deploy Unwrap 3D and Blender at the moment for that task. Always looking for new tools in that domain. Yeah. Hopefully it's going to be a good UV editor. I haven't gotten to it yet, so kind of saving that for last. Like, I'm so much looking forward to making the UV editor that I'm sort of saving it as the lever to pull. Like, whenever I get bored of this project, that's when I pull that lever to make sure that I can see it through. Because I'm like genuinely looking forward to making the UV tools. So how do I imagine it looking like? I haven't decided yet. I have a lot of ideas, but a lot of it is going to come down to like what it feels like to use. So I'm not sure yet. I mean, the starting point is obviously like the same way it works in well, I was going to say Blender and Maya, but more realistically the way it works in Maya, because I didn't like Blender's UV editor. I've heard it's improved a lot with the later updates, but that's the starting point. But there's a ton of stuff that I want to experiment with, involving like, especially when it comes to like your first unfolding. It would be super cool if you could have like an interactive unfold where like you're in the 3D viewport, and like as you're like selecting where to put the seams and you're UV mapping it, having parts of the mesh kind of like unfold and flatten as you cut it, and kind of like automatically like flattening it as you specify where to put all of your seams. So it's kind of like, you can sort of imagine it as like, it's got these sheets that are kind of floaty and you're underwater and they float to the top, like once you cut everything open. And then you can like edit them afterwards. So you would have this like interactive UV editing thing, like peeling an orange, exactly. But that's just like, that's the more experimental approach. And I don't know if that's going to be like, it would look cool, but question is if it's actually like productive and useful and interesting. So the reverse of how you put together a garment, exactly, yeah. Yeah, I'm not sure. There's a bunch of practical considerations there, but it looks really cool in my mind. So I'd probably try it out. But otherwise, I mean, like some of the things that I really like with Maya's UV editor is the interactive unfold. That part was so nice. Just seeing the solver in front of you was so nice. I love that. It was great. And so I just wanted to have something similar. You must decide the main purpose of not only for UV editor, but for how to work with UVs when editing Geo. I've seen several approaches. 1, don't care about UVs when Geo is edited. User fixes in a UV editor. Or 2, preserve texture flow and density when Geo is edited like Trench Broom. Yeah, and like Half-Edge does sit sort of halfway between a 3D modeling tool and then a mapping tool, or like a level art tool, kind of like Holmér, right? And most 3D modeling tools go for approach number 1, and mapping tools go for approach number 2. I haven't decided yet how to deal with those things. I mean, ideally you want the strength of both of them. But I don't know. I haven't decided yet. That's all going to come down to like, once I start implementing some of these things, just getting a feel for the edge cases and what's going to be nice to use. And that's part of the thing that I will enjoy about doing that, because I don't know what the perfect solution is. I just know that there's so much room for improvement, and I'm kind of excited to explore that. Cool, adding back the code that I removed. Apply bevel. Okay, subdiv count, inset distance, and Hey, where's my bevel mode? Maybe I just shoved it in here. Guess I'm not using bevel mode right now, so it actually doesn't really matter. Room for improvement within your work or within the space of UV editors in general? Within the space of UV editors. UV editors, in my opinion, are woefully underdeveloped for, I don't know, for so long. And I just want to make them better. Because I enjoy UV mapping. But I didn't enjoy UV mapping in Blender. Okay. Did I successfully delete code and then rewrote it? Okay, creating junctions, that's per selection. Don't need that anymore. Then we do apply bevel. So I don't know if these actually have to be fields. Why do I have these as fields anyway? Do I need these? Okay. Oh wait, I probably read those values from the bevel junction, I would guess. Because the junctions, yeah, okay. But then this shouldn't be read-only. How do I read them in the bevel junctions? Yes, I am using Unity. Okay, create vertex paths. This is where we need the subdivision count. So we also got the edge inset distance. But that's passed in, that's okay. You know what? I think we can just pass this in. Let's just do that. Oh yeah, the vertex path stuff. This is the code that I need to fix to fix the two vertex or two edge intersection. I think. Yeah. Or is that here? I feel like I'm missing half of the code. This is adding the vertices. Okay, I think this whole thing has to be refactored. I think especially because the vertex path stuff is kind of messing up some of the code that I did recently. I think, how would I do this? I guess I would, what's your favorite food? What is my favorite food? It's kind of hard to pick just one. You need ideas for dinner. Well, I don't really enjoy cooking, so most of my dinner stuff is very boring and basic. It's like whatever's easy to cook. Chili con carne is pretty good. I like that. I like, you can do like a like a satay sauce wok type of thing. That's kind of nice. There's a, I don't know. There's a lot of options. Don't listen to me when it comes to cooking. Okay, so the vertex path thing here is kind of tricky because I can't always make all of these use the same code path. It's gonna be kind of ugly regardless. The question here is basically where or who has the responsibility to create the boundary vertices for a bevel junction. So when you have three edges meeting at a corner, you have the three yellow boundaries here, and then you want to create vertices along each of these boundaries. The way that I do it now, it's kind of this edge's responsibility to create these vertices. So each edge creates their own set of vertices, but it doesn't fill the gap. And so the gap filling right now is like an entirely separate code path. And that code path is the one that has the, you know, the triangle geometry shenanigans, right? Which is a little bit annoying because it would be kind of nice if I could just take the triangle stuff and this one would be responsible for creating every vertex and not, well, except for the corners, because that would make it easier to generalize this code. But the problem with that is that sometimes there is no triangle. Sometimes you just have two edges meeting. And in this case, there's no patch. It's just it's like a degenerate form. And so in this case, it's different. So I can't use that big patch thing. And so then the question is, should I make this degenerate form like part of the patch, or should I or should I like branch that behavior earlier? I feel like it would be nice to make that part of the patch actually, so that I can just generalize the whole thing. Can I ask you how you document your code of projects? What software do you use? What type of documentation do you prefer? I don't really do, like... I mean, when it comes to documenting my code, I guess, like, this is one type of documentation. So these are just my notes, like, visually. I have all of these notes, which sometimes serves as documentation, depending on what it is I'm working on. And then I also have notes in Obsidian. So I use Obsidian whenever I need to, like, I don't know. For example, I have a list of people who are signed up to the private alpha testing. So I have a list of people who have signed up to that, right? So stuff like that. It's things I really need to remember. But then I also have sometimes like inline documentation in code, like the XML tags. I sometimes add notes there, but that's pretty much it. Kind of depends on the magnitude of the task. Okay, so I think the bevel junction should maybe have the tessellated cap thing. Okay, so then the question is, what should that data type look like? Where was my drawing? I did a... Oh my god, I'm lost in my documentation. It's over. I remember drawing these pretty recently. Did I not? I mean, I guess I was here. Wait, how would... Let's see, how would this differentiate in this case? It's gonna be hard-coded regardless. There's gonna be exceptions. There's no perfect solution here. I think I just need to pick one and then stick with it. Okay. So the junction then has... Yeah, I think I'm going to make it so that the junction has the responsibility of creating that tessellation and also managing the boundaries. Yeah. Okay, it's going to be... I think that the way that I want to set this up is a little bit messy. It contains some duplicate data, but I think that's okay. Yeah. Okay. Let's see. Do I create the Bezier on a per edge basis, or... Yeah, I think I actually do. But then the cap has to read... Maybe the cap actually needs to know the tangents. Sorry, I'm just thinking out loud. Or no, I'm thinking silently now, but... oh, and also thank you for the dono, Ramon. Where would I sign up for alpha testing? So right now there's no public sign up. So right now it's kind of just based off of my own whims. Because I am trying to selectively make sure that I pick people for the alpha who have actual use cases going right now and who have like professional experience in game dev. Which it sounds like you do, which is good, but there's no public sign up, so I can't promise anything. So usually right now I just kind of like do it based off of people I meet at events or just like random people I see on social media. So basically you have to like convince me somehow, in a way that doesn't look like a public sign up. Okay. So setting up these boundaries, I guess I just feel like it's nicer to have it in one type, actually. I think I'm gonna do that. So we're gonna have a type called Bevel cap, corner cap, I suppose. Even though it sometimes doesn't even have an area. So what are we gonna have here? We are gonna have a understandable, have a fantastic day. Sounds like you're just like leaving immediately. Just like, fuck this. You are allowed to leave though, so that's okay. Okay, so the bevel corner cap. Here we've got the bevel junctions, or no, the bevel half edges. Those are the blue lines here. Each blue line can be associated with a single Bezier curve. Do I reference those, or do I just shove it into here? You know what? We're just gonna make some more types. We like types here. We're gonna make little structs. So this is a cap, a boundary, cap boundary. Actually, just cap boundary. So what are we gonna have in here? We are gonna have a it's like the out, I called it direction before. I think I can just call it direction here too. When you're not on stream, do your cats become your rubber ducky for developments? No, they only disrupt. Usually Salad wants to eat my tablet pen. He really likes eating this one because he knows he's not allowed to do it. And Thor likes to sit directly in front of me, usually on my keyboard. He'll sometimes reluctantly sit in my lap instead. I'm just curious, would it not be useful to have people who are brand new to 3D modeling use your tool early for feedback you may not normally see? Not this early. I think it's too early for that kind of stuff. That kind of feedback is really useful when I'm working on like the UX and the onboarding, but that's gonna take a while until I need that kind of feedback. But it's good to have that kind of feedback. I think it's just too early on in the project. And the problem with people who are new to like a specific tool is that they might not really have the same use cases that someone who has existing projects have. So usually people who are inexperienced, they might suggest stuff that's not super relevant, or they're suggesting stuff where it's just kind of the wrong tool to do that kind of thing. Yeah, so I think like experienced users have a tendency to focus on the more important stuff, for the most part. So I don't think it's like completely useless to have that kind of information, but I think for that kind of testing, I would honestly prefer to have that kind of thing where like I would watch people use it for the first time, like that kind of testing, rather than sending it out to people to have them test it in private. Okay, direction seems weird. This should be outgoing. Tangent is confusing because the cap boundary also has tangent directions. This is like outgoing, half edge. Actually, let's just call it outgoing direction. Or no, outgoing edge direction. There we go. Very, very verbose. And then each boundary is also going to have a Bezier curve. So Bezier, cubic, 3D. Bezier. And what else? I guess a reference to the Bevel half edge, actually. And from that, I can get the direction. So I don't even need to have the direction there. Okay, so this is the boundary curve. All right, so I think we're on track. This is good. So this is going to be the boundaries. No, boundary splines. No, boundaries. Or the boundary even. You're doing passes or corner by corner? As in, what do you mean? like right now the corners are independently processing in whatever order it turns out to be, which was somewhat non-trivial to make that work actually, but it works. So okay, bevel corner cap. So this should be initialized from a list of bevel half edges, I suppose. So I guess we'll make a constructor where we pass in, oh, bevel half edges in junction. Okay, yeah, that's the one I want. Okay. Wow, Julian calendar. Okay. Cool. Then we need to set up the boundaries. Should this one... No, the boundaries are not dependent on... Oh, they're not dependent on tessellation or subdivisions, but they are dependent on radius. But that's just like recreating them. Yeah, okay. So I guess we'll make a function called recalculate boundary. I think we should just call it in the constructor. Okay. Although, do I pass the subdivisions in here? Or no, the edge radius? What did I call it? I had a good name for this. Edge inset distance, that's the one. Okay. So basically, the idea with this function called recalculate boundary is to calculate these Bezier curves given the edges you've selected in your bevel on a per corner basis. So that's just the boundary, not the whole patch itself. So the patch is going to come later. All right. I'm trying to think if there's edge cases here or if I can take a shortcut. What are the situations? So like, what do I do in this? That just depends on how I define bevel. I guess regardless, I'm gonna have a Bezier per curve. So I think I should just make it so that those Beziers are created here for starters. So we're gonna iterate through the junctions bedges, which is a bevel half edge. I wanted a short name, veg. Why am I not allowed to press return? Okay, and then this is where we're going to do the Bezier curve code, which I've done in 2 different places, which is not ideal. So get vertex arc is the one that I had last time. Oh, this is the one, yeah. Okay. Yeah. This is the one. Okay. This should not live inside of here. I'm just gonna yoink this out and deal with the consequences. See, this is why I like languages with types and predictability. I really like the fact that I can just be guided by errors when I'm refactoring. If I like forgot what to do next, I can just be like, oh, I'll just go to the next error. And I can like cycle through all the different errors to just clean things up. But if I'm using something like JavaScript, it's like everything is allowed. I can like call functions that don't exist. A typo is not an error, and it's all just like super loose, and I don't know, it makes me lost. Okay, let's see. Okay, now I jumped too much though. Okay, so this is in the what code? This is in create vertex paths, right? Bed makes me picture Pepe the Frog tucked in bed. It does kind of sound like... Or no, wait, yeah, it's kind of like Sag, but bed instead. But I don't know if... Do people use the j, like, suffix for things that are not sad? I don't know. I only know of Sag, so I don't know if there's other uses for it. They do? Like, well, what's another one in the j series? I need to paste this somewhere. Right. It should go in here. Madge? Fridge? Fridge is good, I like that. Okay, I pasted it too many times. Okay. So this gives us a boundary. So we're gonna make a new cap boundary. And we are gonna write some incorrect code. And we're gonna okay, so first the bevel half edge. So that would just be bench, and then we've got the Bezier curve. And then... Oh wait, it's not, hold on, I'm dumb. It's not a constructor. Okay. That's good. Position would be bench.position. Bench.spoke. Mesh. That should live in junction, actually. It does not. Okay, weird. Weird. Where's mesh? Bedge is an emote? Wait, like, where? Direction. Yeah, that's the bedge direction. Whoop. Okay. We got our boundary. Then we just need to plop it into the boundary. So boundary.add. Okay. Why do I not need edge inset distance? Oh, because I've already separated the mesh. And so the current vertex position actually is already containing that distance in and of itself. Okay. We're already inset at this point. is good to know and remember. Okay, boundary. What is happening here? It's never used. Well, I'm not done. Jeez, chill. Okay. Okay. So now recalculate boundary is per selection, but then I guess just to be safe, I'm gonna clear the boundary when doing this in case I call it multiple times, which seems likely. And I suppose this is where I should who's going to be responsible for the vertices? Who has ownership of those? It's gonna depend on how I set it up. I don't have to stick to the way that I did it before. It just feels like I have to, but I really don't. I'm just gonna write what I think is nice, and then I'm gonna deal with the consequences later. Okay. Oh, that's not public? Okay. That's not public? Okay. That's not public? Okay. Oh, that's not public either? Okay. I guess I can use the built-in refactoring tools instead of wandering around like a fool. Okay. These... I can move this in here. Okay. Time to separate this out. This should go into its own script. We're gonna make it clean. What's this color scheme? This is a, I think it's Visual Studio Dark. And then I changed the background color to my, like, brand background color, I suppose. Okay, create vertex paths. So this feels kind of hard-coded. But I don't know if it is. It just really feels like it. Where like every like outgoing edge has like a list of vertices. And then when I do the straight connections across, like along each edge, I just read from those. But I feel like it's the caps that should be responsible for keeping track of those vertices, not the edges. So I'm considering not storing those in the bevel half edges anymore. You need to look into the NURBS book. It'll help a lot with this. I don't know if it will at this very moment. Or like, was there anything in particular there that you would recommend, or? Okay, wait, where do I call this? That's in the beveler. Okay, why am I passing inset distance subdiv count? Okay, so here I get the vertex arc, but it's no longer in the bench. But this is where I do create those vertices. Just joined. We use it for cat apps. You may be taking a more fun new approach. I mean, I know what NURBs are. Yeah, I mean, it might contain stuff that would be useful. I just don't know what specifically it would be. So, do I remove this whole function? I really don't like the way this is set up. But okay, maybe I'll just pretend that's good code. I guess the thing I have to do is filling out the faces. But didn't I already do that? I remember trying this. Okay, where's my quadrangulated? Or did I use my old code for that? Because the quadrangulated is relatively new. Yeah, I'm just using that in my test code. Okay. That's useful to know. Okay. So I think we can kind of do this in 2 steps. So first step would be to keep a lot of the edge vertex code, but just kind of redirect this. So then instead of creating a new spline here, we're going to read off of the... Or no, I should just... Oh yeah, because I have to insert those into the face. Right. Okay. Right. Okay, so here's the thing. Let me just show you what I saw in my head so that it's a little bit more tangible. Okay. Basically, when you're beveling a corner like this, oh, the mesh is going to break, so I guess I can't click, but you get this cap mesh. But if you select these 2 edges, you get no cap, and then you have a single Bezier curve where these 2 bevels are kind of joining at a sharp corner. But when you only have one selected, it's like that's even less of a cap because you're now adding vertices to an existing face. You're not adding vertices outside of existing faces, you're adding to a specific face. That's the case when you bevel a single edge like this. Wait, why could I not? I'm getting errors. Oh, it's this thing again. Okay, that's fine. Right, okay, so should the cap mesh be responsible for doing that as well? Probably. I feel like it's like it's a better like centralized place of doing it. Okay, will it work now? Yeah, okay, there we go. Yeah, see how it like adds vertices to this face? That makes me wonder for the N over 2Ks, is there a reason not to support the sharp Bezier joins? I guess it depends on what the sharp Bezier joints would be. Do you mean like the intersection of all 3 straight continuations of each like bevel, or because I'm pretty sure, I could be wrong actually, but I'm pretty sure the moment you have more than 2, they're not going to intersect at nice locations. Like I I don't think the topologies are going to align, which is going to make things messy, I think. But I could be wrong. No, these vertices actually, these should just live in the... Yeah, you know what? Yeah, I should not do this here. This code should just not be here. Okay, I'm gonna start deleting commented out stuff because it's distracting me. So let's just boil this down to the bare minimum. So I think all the stuff we're doing here should be part of the same code. Why do I create edges? I don't need to create edges. Maybe I just did it because I thought I had to, or because or maybe it was because I was like using them to debug to make sure that I got the connections right. But we don't need that, so I'm just gonna remove it. Okay, so this vertices across. This thing is not gonna be here anymore. You know what? Just gonna delete it. There we go, it's gone. And we're gonna instead put that in the where'd it go? Bevel corner cap in here. So that's gonna live inside of the cap boundary instead. So this is now going to contain the vertices across. Jesus, my computer is like taking off like a jet right now because I haven't optimized the rendering. In which case I feel like this should be a class now because I have a like reference in here. Or I guess I had before as well. I feel uncomfortable having structs that contains list data. I don't know, I just don't wanna. So it's a class now. That's just the way it is. Okay. So we got cap boundaries. I'm gonna move that out because it's confusing me. Okay, cap boundary contains the vertices across, which means that I guess I can just populate the vertices here, actually. That's a much better place, I think. Then the question is, do I have access to all of the badges that I need? Because I think this might be pre-filtered in a way that might make this trickier because... Or no, I'm actually checking for only Bevel spokes here. That's good. Oh wait, I'm not doing that in the other one though. Okay, that's a problem, because I do need to do that. We're just going to start tearing this code out. Are you going to support OpenUSD? Potentially, haven't decided yet. I think GLTF is probably more likely in terms of those two formats. I think USD is a lot more... I feel like USD is very like animation and film centric, but GLTF is a little bit more real-time centric, is my impression. I haven't like super dug into both of them, but sorry if this has been asked over and over, but what is a half edge? I know it's the name of software you're building, but is it an actual thing? Yes, it is a thing. So here's what a half edge is. When you're creating a 3D model, you generally have a bunch of points in space. Usually we call these vertices, right? So we got 3 vertices. That's the minimum amount required to make a surface of some kind, and we call that a triangle. In order to connect those, we usually call these things edges. So edges just connect a pair of points. But then there's something else where we then want to define a face here. Because if we just have edges, there's nothing telling us that there's a face that should connect these edges. And you can define faces in various different ways. For example, in real-time rendering, faces are usually just defined by index. So it's always a triangle, and a face is just 3 numbers in a row. So if it says 0, 1, 2 in a row, it means that there's a triangle filling between those. But because this is not a... Like now I need some kind of topology that's for mesh editing, not just rendering. So I need something that's a little bit more flexible in that. And one way to define a face is to set up a data structure called a half edge. So a half edge is kind of like an edge as it belongs to a specific face. It's also a vertex. You can sort of think of it as the unique vertex data for this triangle and also the connectivity data for this triangle. So this face would have 3 half edges connecting in a loop like this. And so half edges have a, they basically point to the next half edge. And so all of these half edges know which half edge is the next one. And half edges also know which vertex is at the base of the half edge. And the reason it's useful to have this kind of data structure, well, one is that faces are defined by just a reference to a half edge. You just need to know one half edge of a specific face, and then in order to know what face that is, you just like loop around all the half edges, and then that gives you a face. So that's how you define faces using half edges. But a really, really important thing with half edges is that it allows traversal across the mesh. So if you have another triangle connected here, half edges also have a reference to the half edge on the other side of the edge that they're connected to. Sometimes some half edge models don't have the concept of edges, like these orange things, they just have half edges. But for various reasons, I have edges in mine. And so when you have this kind of data structure, it becomes very easy to like traverse the mesh. If I want to get all the neighboring faces of a specific face, I just iterate through every half edge, check if they have a neighbor or a twin on the other side. This one does have a twin. It's this half edge right here, right? Then I can iterate through these half edges until I find, or maybe the half edge itself has a reference to the face. And then I know which face this belongs to. And then maybe I'll do that like recursively. I'll keep on iterating over each half edge to see if there's any other connected faces. Like this kind of traversal of checking, you know, the next half edge and the twin half edge, and then the next half edge, like you can do a lot of different operations using this simple setup. So basically it makes mesh operations so much easier because you can jump around the geometry much, much, much faster than you would a like the traditional like GPU friendly setup. Because in GPUs, you have no connectivity information. You just have triangles in a big list, and you have vertices in a big list. So if you want to know like what triangles are connected to this face, that is a search operation, meaning you need to like iterate through the entire like data set in order to find the neighbors, which is very, very, very slow. Yeah. I found the part from the NURBS book I was thinking about. It's on page 359, PDF available for free online. This is the rational continuous parametric geometry approach. Hope this helps. Well, what is that part about? Why do you even support Mac? I saw in FAQ that it's supported and got me surprised why. And do you even work on Mac? Sometimes. My laptop is a MacBook, but I generally work on my desktop, which is Windows. But also it's because I'm working in Unity and it's relatively easy to port stuff to other platforms in Unity. And it's a half edge because it's only one half of the edge that might be for two different triangles in this example. Exactly, yeah. Yeah, that's why it's called a half edge, which is a bit of a weird name. It's also a little bit weird to just call it an edge because half edges are also additionally used for face-specific data on the vertex that's at the base of the half edge. So half edges are kind of a combination of an edge and a vertex, which is why I usually draw them like this. I usually draw them with a dot at the root and then an arrow for pointing to the next one, so that it's kind of referring to both this edge and this vertex. That's the responsibility of this half edge right here. And yeah, the name comes from the fact that not always, but usually two half edges form a continuous surface, because then you have a face that goes across an edge, and every half edge, in most cases, can only ever have one twin on the other side. At some level, this is like turning the geometry of a shape into a directed graph. Sure, yeah. Just anything that you're able to traverse, right? Did you trademark the name half edge? Nope. Did you get the domain? One of them. I got halfedge.xyz. So half-edge.xyz. So sort of. I have one of the domains. And I do think that .xyz is actually particularly appropriate for half edge. The only thing I don't like about... Actually, that's a problem with the name in general. I don't super like the fact that I have a hyphen in the middle of the name, because I'm never quite sure if people are going to be consistent with that, or if people are going to leave it out sometimes, or I don't know, or if I should keep it in the URL, or if it just be half edge without the hyphen. I don't know. I don't like it when you have names that can be like represented in multiple different ways. But that's probably inevitable. Half-edge LLM edition. Wait, hyphen? Did I mean hyphen? Wait, are dashes and hyphens the same thing? Wait, isn't... Am I mixing it up with, like, accents in my head now? I don't know. You know what I mean, though. Right, yeah, so this is what half edges are. It's just a convenient data structure. And this is a thing that's been it's existed for a long time. Usually, I think usually half edges show up in a data structure called like decel. Yeah, which is like doubly connected what's the E and the L? Edge, I forget. It's a thing. I know it's a thing. Let me look it up. Wikipedia. Easel. Edge list. Right, that's the one. Decel. There you go. Doubly connected edge list, also known as half-edge data structure. It is not, the one that I have is not quite this. So for example, I don't have a doubly connected list. I have a singly connected one. But the core idea remains the same pretty much. I also have edges, but a decel generally doesn't have edges as a separate thing. So in that case, you would just have you would remove all the orange ones, and then edges would just be the like consequence of having half edges anywhere, pretty much. Wait, what was that? Page down? You can use page down in Photoshop to like jump to the bottom, okay. Okay, anyway. I have a drawing tablet, yeah. Okay. So. I guess I'm gonna just move pretty much all of this. Let's see, what do I do here? Vertices across. Right, okay. This is like a weird optimization thing that I don't think I super have to care about, but I might want to keep this cut around. Probably a very basic question, but is there a custom render pipeline that can work with the half-edge data directly, or is there a translation step to build triangles for displaying on screen? There's a translation step, yeah. So the GPU is still gonna want to work with triangles or any other supported primitives that it has. So there is a translation step, but that's kind of inevitable because there's other data that I need to compute before rendering the mesh. So like one of them is vertex normals, because vertex normals are downstream from the data. And so I need to compute the vertex normals in order to make it render properly. And so in that step of computing the vertex normals, I might as well just do the computation step of just converting everything to triangles and sending it to the GPU. So that stuff I am already doing. Okay, this thing is not going to be a thing anymore, so that one I can remove. I feel like the n verts across used to be subdiv count +1. Am I? Because it should be like one more, right? I'm just gonna do +1 because that makes sense to me. Maybe this is a bit outside the scope. Why don't GPUs use half edges for storing and computing mesh data? It feels like it would save lots of time. So GPUs don't need half edges. So it just adds more data that they don't need. And so the way that GPUs get their data is very much the bare minimum. It's just the least amount of information in order to render the things you have to. And so that's why GPUs are generally, generally the data on GPUs, it's kind of like, it's two different streams of data. So first you have the index buffer, which is a horrible name. So the index buffer is just a technical artist way. If you want to sound cool, you say index buffer, but what you really mean is like triangles. Usually. You can use index buffer for other things, but in most cases it's triangles. So an index buffer is just an array of integers. So it's going to be like 0, 3, 1, 7, 11, 8, and so on. So it's a bunch of indices, a bunch of integers. And the way that they're used is that each triplet is a triangle. So each of these defines a triangle. And what the indices here refer to is that they refer to the index of the vertex array. So you have a bunch of things called vertex streams. And there's usually multiple, because there's multiple sets of data for each vertex. So you can sort of, usually you have things like the position of every vertex is like a required one. So the position is just a bunch of vectors. Again, it's just a bunch of floating point numbers, but you can think of it as an array of numbers as well. So here you would have like the actual coordinates, you know, the XYZ coordinates. And so on. And then you have the same for normals. So this would be vertex normals. Same thing there. You have your vectors. You might have vertex color. You might have UV channels. So this would be like UV0. You can have multiple UV channels. So UV1 and so forth. And so when the index buffer has an index that says like 0 or 3 or whatever, basically what it's saying is that 0 means the 0th element in all of these buffers. So this triangle can then access the data that's associated with vertex 0. Yeah, and there are a few like weird consequences of this. So one of them is that, for example, if you have a cube, like a standard, straight up, honest to God default cube. There we go. A standard cube. You might think, oh, okay, so it's a cube, and how many vertices does this cube have? Well, you would have 1, 2, 3, 4, 5, 6, 7, and then 1 behind here. So you'd think this would be 8 vertices. But the thing is, the data structure that we have here doesn't actually allow us to only use 8 vertices for this cube. And the reason for that is because if you look at the properties we have here, we have the position, we have the normal direction, and the vertex color, UVs, and so forth. If we want the normals to be different around this vertex, which we usually do because, you know, the normal direction at the top here, we want this to point upwards for the top face. But for this face, we want the normal to point in this direction, right? And for this face, we want the normal to point in this direction. And so because the normal data has to be different for the triangles that meet at this vertex, we're gonna have to duplicate the vertex data. So every single stream is gonna have an additional one that contains the unique normal for that specific vertex. And this feels wasteful, but the thing is, it's just designed to be rendered as quickly as possible. So the extra like duplicated data generally is fine. And so you just have that duplicate data and that's okay. And it's going to render super fast because we don't need to do any like checking of neighbors or references to stuff. It's just kind of very like stupid, straightforward, just do this thing and then it does that thing. So it's very much optimized to render quickly. But then, you know, that leads to these weird things where if you consider the number of vertices in this mesh, well, you would need multiple like vertices on each location. So yeah, each corner would have 3 vertices on the GPU. And so for the GPU, the vertices you have on the inner side here, I'm just drawing them on the inner side, but they're at the same location, are actually more analogous to half edges than the vertices you have in a 3D modeling app. Because the vertices you have in a 3D modeling app, they join all of these into the same thing, right? But yeah, and so anytime you have a vertex where each face wants different data, either because it's a hard edge, because as in the normals point in different directions, or you have a UV seam, you want to separate the UVs at that corner. You want to have, when you want to texture this thing, you don't want them to share the same UV coordinates, then you also need to separate them for the GPU. So any data for the half edges that you want to be different around a vertex is gonna split the vertex. Yeah, but then you can, of course, in certain cases, if you don't need these to be different, you can also merge them into the same vertex. So it really depends on what you're actually doing, but you can share many vertices in practice? Yes. So anytime you, like, I don't know, if you have a smooth surface of some kind, it's usually tessellated into multiple quads, right? And generally, for meshes like this, you can generally just have one vertex for the intersections here, like along a continuous surface. They share the same vertex normal, they share the same UV coordinates, like all of these vertices in the middle, they can all just share the data. But then the moment you have a hard edge, like you have a hard edge here, and then maybe you have some other geometry, and you want to have a UV seam along this boundary, then you're going to duplicate those vertices on the GPU side. So seams is generally what's causing these things to duplicate. Okay. Why was I explaining this? I forget. Oh, someone asked, I think, about why GPUs don't use half edges. So it's mostly just because the data retrieval becomes very, very, very simple. Like half edges are a little bit slower for data retrieval because if I want to get the, like, Like half edges are designed to work with n-gons, but GPUs generally just work with triangles, and it can assume triangles, and then they don't have to check. So they don't have to check for triangles. All it needs to do is be like, okay, this triangle has indices 0, 3, and 1, so I'm just gonna fetch all the stuff from index 0, all the stuff from index 3, all the stuff from index 1, and then interpolate between those, and then we're done. But for half edges, it's not as simple as that, because you need to like traverse to find the next half edge, and if the next half edge is somewhere completely different in memory, then that might slow things down as well. And even just having to iterate through all of these is just slow. Yeah, so things work a little bit different on the GPU, and once you have like a finalized exported render mesh, you know. Basically the only real point for having half-edge data structures is just because it makes manipulation easier. Manipulation, traversal, anything where you need to modify the mesh. But you know, GPUs don't modify meshes. Well, you can sort of make a case for that they do in some cases. If you do like tessellation shaders, and in my case where I use compute shaders, but that's kind of a separate thing, I suppose. But generally GPUs just like, they take mesh data and they display the data. They don't modify data. Well, they modify it, but it's just modifying the individual points of data before display. They don't do like traversal and things like that. Okay, I need to go to the bathroom. Okay. Oh yeah, there's an add button. I'm gonna go to the bathroom and press the add button. So I will be right back. See you all in a bit. Watching her work on half edge is cool. Thanks. But the reason I come by the streams is to hear her explain stuff like this. She's quite good at teaching. Thank you. There will be a test after. Exactly. Gotta stay sharp. Sorry, I forgot that I had the mic muted, or semi-muted. I need to get a proper mute button. Are there any audio people in chat? if there's like audio people, is there a mute button that I can get that is a true mute, as in it actually disconnects the audio, but it doesn't pop? I want a pop-free actual pressing down to negative infinity decibels. Is that possible? Or, because I sort of got the impression that like you can't have both. It's either fully disconnecting or with a pop, or you don't get fully disconnected but there's no pop. If you're using OBS, why not mute from there? Because I don't trust software. I want to have a single button that works across every single application, meaning it's just going to mute my microphone instead of muting my microphone in one specific case. The math for a smooth ramp is easy enough, but I don't know what existing software would make this easy. This is not a software thing. This is a hardware thing. You can do without a pop. Might take very slightly longer though. I think that's fine. It's okay if it has a bit of a fade. I mean, I think that's, you have to, right? Otherwise it's like doing it instantaneously is definitionally going to cause a pop, I think. I'm not a software dev. I'm a technical artist. So, and I'm gonna draw that arbitrary line right now. You know that some mics have mute buttons, which is really convenient, but mine does not, unfortunately. Where's my tablet pen? There it is. Usually the pop is more than just the abrupt cutoff of sound though. Yeah. Yeah, I think... Yeah, it's specifically an XLR connection. And I don't think it's a... No, it's not phantom powered. I think if it was phantom powered, it would make things a lot harder, but it's not. And so the mute switch is sitting on a unpowered XLR. You know, I'm not going to do it in software because I don't want it to mute just in OBS. I want it to mute everything so that if I'm in a meeting or in a Discord call or in a Zoom call, like I want it to work across the board. That's why I want it to be hardware. Is there a difference between a dev and a technical artist? Whether or not they own a drawing tablet? That could be probably one of the lines. But I do think that I think most technical artists probably lean more on the tech side rather than the artist side. I think there's some, you could argue that some parts of like doing VFX falls into the category of tech art. Tech art is a really weird category. Yeah, I think like if you do VFX people tend to be sort of more on the art side rather than the tech side. And I think you could argue that they are also technical artists. But yeah. I've always found debugging shaders difficult. I recently stumbled on RenderDoc. Is that the better tool to put time and energy into? I pretty much almost never use RenderDoc. But I also use Unity, and Unity does have a pretty good, what's it called? Frame debugger? I think it's called frame debugger. So Unity has a thing called the frame debugger, where you can kind of step through every single draw call. So this is extremely useful for, not for like individual shaders, actually kind of, if you just want to see the input data and the output data. But like stepping through a rendered frame is really, really nice. I don't know what you would use outside of that, if you have like a custom engine or a different engine. Okay. How do you juggle discrete math geometry and continuous Bezier geometry? I use the continuous stuff to generate the discrete stuff. It's right now it's just one way. I don't have any like persistent spline based stuff. Okay, so create vertex paths is I'm basically gutting this function. That's what I'm doing. Why did I turn this into a function? I don't really need to do that. I guess I was supposed to use it here and then I didn't. Okay. Okay. Whatever. I'll just move it here. Oh, someone asked if I had a computer science or art background. I mean, I don't really have any background when it comes to like my education. I mostly, so for like high school, I did natural sciences. There was a little bit of programming there. Yeah, natural sciences and like, there was more math there than usual. So it was sort of math focused. There was some additional like programming things. But the programming things were like very basic. Like I was ahead of like my teachers in that, so that wasn't really useful. Oh wait, am I gonna need that in the inner loop? Probably. So let's steal that one too. But after that, I went to like a vocational school called Future Games, and at Future Games, I had a 2-year, or more like a 1 year, and then the other year was like internships. But that was a specific like game dev focused thing. And at Future Games, I went to they had like 2 different courses or 2 different branches. It was either the artist one, where you did everything from like sculpting, 3D art, 2D art, concept art, like whatever you might want to do. Some VFX stuff as well, UI art, that kind of stuff. So anything like art related. And then I went to the one called design, which was primarily game design. So that included stuff like level design, and proper like designing game mechanics, and UX, a little bit of psychology, which was really fun. And then also a little bit of programming there. And so that's when I got introduced to Unity for the first time. Back with Unity 3, I think Unity 3 had just come out when I started using Unity. Okay. Let me try to navigate. Where was I? I was doing the Bevel corner tab. Right. Okay. Is this just for art or is it for something? This thing? I mean, I'm making a 3D modeling tool. That's what I'm working on. So I can run it so you can see it in action. Maybe, unless I broke stuff, but. So I'm making a 3D modeling tool. This is the thing that I'm making. It's for making 3D models. So it's kind of like Blender, except it's not Blender. Yeah. Oh, I broke the rotation code? No, okay. Did I not fix this? I remember fixing this. Well, I guess my rotations are broken. That's okay. It's a really good 3D modeling app, you know? Because you can't do this in Blender. Can Blender do this, you know? Anyway. So that's what I'm working on. It's a 3D modeling tool, and it's one specifically made for game development. So it's going to be a little bit different for that specific reason. Oh yeah, I was going to have the... Right. Okay, so I'm going to make that into a variable. That's what I was working on. Oh right, I can't call it boundary. Okay. Let's see. So here we got the edge boundary, and instead of vertices across, I'm going to do edge boundary dot vertices across. The list of features not included in Unity is growing by the minute. Yes. What graphics API do you use? Well, I mean, I'm using Unity, so it's like whatever I compile to. So if you're asking about like the rendering platform, I guess right now I think it's DirectX 11, but Unity cross compiles to whatever platform I want to target. So if I want to do like Mac builds, it's going to target Metal. If it's for Linux, I guess it's going to do Vulkan, or you can do OpenGL. Okay, so this calculates the boundary, but then I'm also getting the vertices. And this is where we need to ask the question of, should the vertex positions be defined by... No, I already know the answer is no. It should not, actually. The answer is no. Good. Okay, then I know then I know how to do this. I wonder if I should pass some data into this. Does this work off of points and vertices like VisPy in Python, or is it grid-based? I don't know what VisPy is, and I don't know what you mean by points and vertices. I mean, it's a polygonal 3D modeling tool. It's not grid-based. It's you can put stuff wherever you want, floating point precision locations. But yeah, I don't know if that answers your question. Okay, so the cap boundary should probably be responsible for getting the initial vertex, I think. So we got the start vertex and the end vertex. We're kind of doing that here. Guess I could put that in the constructor maybe? No, nah, I'll just leave them as properties. So that would be these two. Do I still call them vert0 and vert1? Vert0 is going to be fine, but vert1 is going to sound like it's the second control point of the spline or the curve, but it's not. So that might be confusing. I could call it like vert t0 and vert t1. That's actually better. But then I can't use lowercase t because then it's going to look at vert with two t's. But I don't like doing that. But I can't do capital T because that looks wrong. Actually, I guess it's okay. But I don't know. I don't know. I guess it's okay. Yeah, let's call it bench. Ooh, mesh. Do we have the mesh? Because maybe the bench has a mesh. Didn't I actually have... Oh wait, it's the target of the across. Okay, right. So it's not just across, right? Okay. Pascal case problems, exactly. What do you think about coding agents like Claude, for example? I don't like them, and I don't use them. I've tried a few times using ChatGPT, and it was some of the most frustrating things I've ever touched. And I also don't like AI technology in general for what it's doing to humanity and creativity. And I think it's in general just making society worse in every single regard. And so I have no love for that technology. And so I just very, very, very rarely use it. Okay. So let's see, we got the vert T0. No, right, okay, so this is the thing that I shouldn't do here, I think. But this is important to consider. You know what? I think... Yeah. Okay. Okay. This should be a function in the boundary. That's what this is. So then the question is, when do I insert T0 and T1 in this actually? Unless I guess I can just pre-populate it. Like in the constructor, I can just add T0 and T1, and then when you add a vertex, you just insert instead of add, maybe? That kind of makes sense to me. Do I add a constructor? Is this the thing I wanted to use? No. Okay, well, rip. Okay. So, we got the bench. Bezier is going to be generated later. Vertices across. Yeah, we're just going to do vertices across dot add. And we're going to add bedge.vertex. And we're going to add the vert T1 as well. And then instead of doing this, we can just do vertices across 0. And vertices across last. Actually, I guess vertices across is the wrong word for this, because the boundary represents the whole boundary. I'll just call it vertices, actually. Do you use Swedish keyboard layout? I used to, but I switched like 2 years ago or something, somewhere there, to the ANSI or the US layout. Okay, and so then we need to have a function to add a point to this list of vertices, which has a bit of a weird exception because in some bevels you want to add it to existing geometry rather than creating a new thing. So that's when you have, if you bevel this one, we want to create new vertices that are attached to this face. So it's kind of a special case, and that special case is going to be handled inside of here. So we're going to do add vertex. So I guess we got the position, and is that it? Yeah, because it's going to create, yeah, we're going to call it insert vertex instead. Yeah. And so that is basically going to... Yeah, branch based off of this. Guess I'm just gonna compactify this a little bit. Where's the, right, the mesh is there, okay. What did I call it, mesh data, I think? Okay, so this is just for the evaluation. Okay, so that is the part that we want to extract, put in here. And then I'm hearing suspicious sounds from the bathroom. So it's probably some kind of cat shenanigans going on, so I'm just gonna double check to make sure that Gumpy's okay. Okay, Gumpy was not up to shenanigans. Like I walked into the bedroom, I just like looked in, and there's this like little favorite little shelf thing, and Gumpy was like in this shape. This was the shape of Gumpy. Just like completely face planted. Just like ultra napping. This was the shape. So I'm thinking it was probably not cat shenanigans because she was knocked the heck out. Big nap going on there. Oh yeah, I wasn't supposed to add. I was gonna do insert to not change the last point. At index. It would be the 2, I think. And then the item would be vnew. Wait, can you not do this? Do you need to do new index? I just wanted a new index. Or I guess, what? Yeah, system.index. That's the one. That's the one. Oh, int value from and true. This got complicated. You know what? So -1 is the last one. If I insert on the last element, I'm gonna assume that the way it works is that it makes it so that that index becomes the new element, meaning it would push the existing one forward. So passing the last index is the correct one, I think. Yeah. Okay, I don't use insert very often. How do you like Sweden, by the way? I'm turning into Sweabu, my friends say. I mean, I've lived here for almost all my life, and so I don't really have a point of reference. I've lived in the US for a few months, but that was a very short amount of time. So I don't, it's just kind of default to me, so I don't really know what to compare it to. When do you plan on publishing this tool? It's probably, I can't like make promises. I really want it to be done next year, at least 1.0. So that's what I'm trying to aim for. How are you planning on making the tool specifically for game development? Will it have things for level design and stuff like that? Not exactly level design, more so level art than level design. I'm mostly saying that because I don't want to accidentally commit and to like promising Boolean operations. Because like for level design, you want to like iterate layouts very quickly, and Boolean operations are really good for that, but they're also really complicated to implement. So I don't want to like make any promises for Boolean fast layout iteration workflows. But I do want to have stuff that's generally more level centric, like having a world space grid and a bunch of snapping options and hotkeys to change grid size and like that kind of stuff. But then how far I take that is gonna, we'll see. It's gonna depend, I suppose. Because there's the kind of question of like, should Half-Edge be a generic level editor? And I think the answer is no to that. As in, should it be like a scene editor that you can use for custom engines? I don't think I want to design it to be that, but I also don't want to make it impossible to use for that, if that makes sense. So like being able to insert like markers for like placeholders for objects, and then you attach some data to them, like that kind of stuff would enable you to use it for like level or like scene stuff in custom engines. But I don't think I want to like design it for that, if that makes sense. Okay, we got our insert vertex function. Cool. I don't think we're gonna need these, actually. Okay, recalculate boundary. So what are we doing here? We're doing... we are setting up the boundary. We got the... let's see, the constructor is different now. Oh yeah. Wait, why am I even doing this outside of the... I guess because now I have a constructor, I can just do it in here. That makes sense. So I'm going to move this into the constructor. And I guess, let's see, I guess it would do veg.junction. Then we're just going to assign that, and then do we need this log? Probably not. Actually, maybe. I don't even know what vert 0 and vert 1 is anymore, so no, we're not going to need that. Oh wait, right, okay, hold on, I'm being dumb. I'm being dumb. I know how to type. Don't judge me. Inverts across. Right. This was for iterating through and assigning to the vertices. This is just going to be done by the cap now, so that's not relevant anymore. And this was for grabbing the... Oh yeah, right, okay. Because this was the case when you have like a shared boundary between two edges. And so this code was basically like, hey, if it's a shared boundary, instead of calculating the vertex positions and adding vertices, just use the vertices from the other one, but in reverse. That's what this line is doing. And so the question is, do I add that logic here? Oh yeah, wait, this is the corner cap. I'm just gonna leave the code here, I think. So recalculate boundary. I guess all it's gonna do right now is just add some boundaries. And then I should move that comment to here. Oh my god, my throat is doing that really annoying thing. Ugh. So my throat does this thing where when most people burp, my body just doesn't. And it's a really, really annoying thing to deal with. Because you feel bloated and you can't not feel bloated. And then you get this like pressure buildup in your throat. And then it'll like randomly like escape in tiny little weird sounds across like 5 hours or something. I hate it. It's so annoying. I just hate it. Uh, 3D modeling coding first encounter. Do you have any vids on channel regarding this? I don't have any like videos, like scripted videos made about 3D modeling. Not really. I mean, I do have videos about splines, and in some sense you can use splines for making 3D modeling tools, but I need to just add a note. This is the Gumpy nap. This is RCPD. RCPD is solved by injecting Botox. Oh yeah, I heard about that. Oh yeah, forgot. I don't know if I'm guessing RCPD is the name for that. Yeah, because I remember reading about it a long time ago. But yeah, I don't know if there's like. I seem to remember the last time I checked, there's very few places that do the Botox treatment. And so I just kind of gave up because I just assumed there wouldn't be anyone in Sweden who would do that. So I'm guessing it's like, I don't know. I got the impression that it's something that hasn't been treated for a long time, and there's probably like a bunch of regulations and stuff that treatment has to go through before it would be available here. I could be wrong though. I would love to be wrong. My partner's going through it. They had it once and the dose was too low. They're going to do it again. Okay. Are there any like major side effects, or is it a very like safe treatment? If you consider to create a playlist on it, I'd be a loyal and happy audience. Oh, for like 3D modeling? Maybe. Like I've been thinking about that, and honestly, I feel like I have very like conflicting thoughts on that. For very like selfish reasons. 'Cause like I feel like if I made videos about making 3D modeling tools, I'm gonna I'm gonna basically mostly help my competition, you know? And that feels a little bit weird, especially because half-edge is gonna be like sold as a commercial product, right? And like there's not a whole lot of people who are working on 3D modeling tools, but if I start making videos like that, maybe a lot more people would work on them because suddenly it seems easier, because people tend to say that about my videos of like, oh shit, this thing seems easier now, and I'm inspired by you, and I want to try to make this thing, which is awesome. But if it's like creating more competition, it's like a little bit less awesome for me. So, just like on a super selfish level, I really don't expect someone who needs a guide about it being competition. No, I think it genuinely can be like some. I've had so many people who have like watched my videos and then like, oh, 4 or 5 years later, they're like, I have a career thanks to you. And I'm like, oh shit, that's awesome. Like people's lives changed, like thanks to slash due to my videos, right? So I don't know. It could happen. It could be like I could run into this horrible thing where people get this thing called inspired, and that would be bad, right? Because capitalism says that we can't like inspire people. That's a risk to my bottom line, you know? And so I don't know. I don't know. But it could also be the case that like the vast majority of people who watch my videos are not gonna like ever gonna like create competing software, right? I'm guessing the ratio there is probably extremely like the ratio of people who would actually do that is probably like super tiny. But like even then, the amount of people making 3D modeling tools is already super tiny, right? So I don't know, there's a risk I'm gonna increase the amount of competition by a significant fraction. But that's just selfish me. And also I have a bunch of other video ideas that I still want to make that I just haven't gotten around to. I mean, I do upload my VODs, at least like since I started streaming on YouTube. God forbid there's too easy to use game dev modeling tools in development. For society at large, that would be a good thing. For me, personally, selfishly, for my sales, it would be a risk, you know? And it's already really rough competition. Like, Blender is not easy to compete with. One could probably argue that making a 3D modeling tool is extremely stupid, because of the fact that Blender exists on its own. And like, there's good arguments as for why like relying on Blender is better. Like even if I release half-edge and I get to 1.0, there's like good arguments as for why you might want to stick to Blender regardless, right? So like this is one of those like endeavors that is just almost inherently stupid. But I'm also like, I don't know. I've sort of realized that I need to have some amount of stupid optimism, because otherwise the pessimism takes over and then I do nothing instead, and then nothing comes out, which is worse than trying and failing. Like doing nothing is strictly worse than trying something and then failing at that something. So I don't know. I'm just trying to stick to my dumb optimism, and hopefully magically there's an audience out there, kind of like the same way you do when you make an indie game. Like some people, when you work on an indie game, you have no idea if there's a market for your game. You're just kind of like, you're making a game that you like, and then you just hope there's other people that will like also like that thing, and then hopefully can support you financially for like the next project, right? So I'm sort of approaching half-edge the same way, where it's a huge gamble, it's a huge time sink, it's something that has been tried before and other people have failed. It's like, I don't know, it's just an extremely lopsided project in terms of like the calculus of how much work it is to do something like this, and the chances of this even getting some significant fraction of any kind of market is really, really low. Yeah. It's kind of ironic that strong open source options can dissuade the creation of competitors in a space. It kind of poisons the well in a capitalism context. Sort of, yeah. Yeah, all of that stuff is really, really... I feel like all of that stuff is so complicated because, like, I feel like a lot of people tend to think that if you just remove the financial incentives that capitalism has, then everything is going to work out. But the problem is that, like financial capital is not the only type of capital that people want. So there's like social capital, and there's like audience capture, and there's the attention economy, and there's also momentum of like we're stuck with JavaScript. We could have had a better language for web development, but we are stuck with JavaScript from pure momentum and the ecosystem that's built up around it. It's going to be so hard to like replace JavaScript if we're ever going to do that, right? Like, and that's not because of like that's not because of like huge financial incentives or whatever. That's just momentum in and of itself, right? Yeah, I don't know. Unless you integrate LLM on it, are you planning on a feature like this also maybe for next stages? I mean, I'm a neo-Luddite, so I'm never going to integrate LLMs into my software. Let's see. So we need the actual patch stuff here. I guess I'll just hard code the sampling of that. Okay, dude, I never create bevel corner caps. When do I do that? I need to do that. So that should be in the beveler. God, my throat is just going at it right now. Okay, let's see. Fill holes sounds relevant. Separate and create paths. Right, we didn't create paths there now, so... I guess this is just doing the separation now, so I'm just gonna remove this. Wait, where did I call that function? Excuse me? In apply bevel. Oh. Okay. So I guess we're just gonna do that. Didn't understand the title, so I came by to say hi. Hello. Welcome to Quadrangulation sessions. Why am I passing this into here? I guess I don't really need that. Oh, here's the filling. Right. Okay. Right now I'm on DirectX 11, but I'm using Unity, and Unity cross-compiles to whatever rendering platform you might want to use. So it cross-compiles to Metal, it cross-compiles to OpenGL, Vulkan, or whatever. So you could say I'm using DirectX 11, but I don't really see that layer of it because I'm using Unity. So I'm just using Unity. Okay. Oh my god, my throat is so annoying. And yes, the cat behind me is a ragdoll. His name is Toast. He's a little bit out of focus right now, but you can see him. He's right there. There's Mr. Toast. Okay. This is a bunch of debug code. Do I need that here? Probably not. Probably gonna just move that to the end of this function, maybe. I might want to use some of this. Okay. Okay. I believe this is the main function we're going to move into the bevel corner cap. Because that's going to be the main task of this type. Okay. All right. So what are we doing here? We are creating a quadrangulated triangle, but that's not actually the thing we're going to use anymore. Or are we? Hold on. Oh, we're going to use a Bezier triangle, but not the quadrangulated triangle. Right, that's the thing we're replacing with, what did I call it? Quadrangulated, or quadish n-gon. Great name. And then subdivision count should also be passed in here. Writer, can you, thank you. Okay, sides, subdivisions. I really need a canonical place to access subdivision count. I feel like I'm randomly passing it, and sometimes I'm reading it from fields, and I feel like it should be in junction. Like, I guess not. Okay. Subdivs. That's not how you write arguments. There we go. And I guess this n is the number of sides, which is n. What did I call it in quadish n-gon? N sides. N sides. Okay. I'm not very familiar with YouTube streaming, but are you able to add emotes to your channel? Yes. I think that's possible. I just haven't looked into it. But I'm pretty sure you can add something, but I'm not entirely sure how customizable it is, or if it's like, oh, it's a members only thing, so you need to like enable the members feature or whatever. Oh wait, this is actually not, this is subdivs. Hold on. Oh, because this used to be just 3 hard-coded. I guess I just had a weird way of accessing this. I guess that's valid. It's a really weird way to do this though. I don't need to do that anymore because we have the boundary. Vertices, I suppose. Okay, I'm gonna add a comment because that's weird, but okay. To do, weird. And that was Bevels, okay. So the process of converting any shape into a collection of quads is quadrangulation. Yep, it's exactly like triangulation, but instead of triangles, it's quads. Or quadrangles. Why do we do that? Isn't triangulation simpler and efficient? Because when you're making meshes, as a 3D artist, you generally stick to quads for a variety of reasons. And then the mesh is going to get converted to triangles at the very end anyway. But yeah, it's a workflow thing. It allows you to do stuff like selecting edge loops, edge rings. It's got some really nice properties if you want to do like smoothing, if you want to like convert your like mesh into splines. Like there's a bunch of advantages to using quads. Okay, so let's see. So n sides should be a property. Int n sides is boundary dot count, I believe. Okay, and sides, and I guess corners dot count is just n sides. Oh god, so much of this is going to be different. I might just comment out some that, wait, populating the boundary vertices? I thought I... Oh yeah, because it's a... Right, it's creating a dictionary. Right. Okay, now I remember. Okay. So what did I call that coordinate? I had a word for it, I think. Address. Yeah. I guess I call it index here. Index address. Address is a better name. So I need an address to vertex. So the word address, it really messes with my brain that address in English and Swedish are like super similar. The only difference is that one of them has 2 D's in address. And I keep forgetting which one is which. I think the one with 1 D is Swedish, but I'm actually not 100% sure. I'm like 70% sure, but I could be wrong. So this, like, stop making it so similar. Like, either do the same thing or just pick a different word. Okay, Swedish has 1 D. Okay, cool. All right, my confidence is going to be better than 70% next time. How long have you been using Rider, and do you have any gripes with it? I mean, how long have I been working with it? I don't know, maybe 3 or 4 years? I was using Visual Studio for a long time. I forget. Okay, but this time it's an int 3, not an int 4. Okay, commenting that out. Okay, populating the boundary vertices. This is important. How do I deal with teammates who uses AI for coding? I hate all current AI stuff, but feel hopeless. Yeah, I don't know. I don't know about that one. I don't have any good answers. Judge them swiftly and deeply whenever you're standing near them. Just like judge them, look at them when they're using AI. Until they feel shame. That's the way to do it. Okay. So the boundary vertices, all we're doing here is we're associating an address with a vertex ID, and we've already created the vertices. So, yeah, I think we just need to pull the things we have in our boundaries. So for each. Oh, do I have any gripes with writer? Absolutely. There's something wrong with the parameter pop-up thing. Whenever I want to see what arguments I can pass into a constructor or function, it like works 50, like, or no, not even 50, like 10% of the time. Like, I just want, just show me the parameter list. This thing, this, I want this. Like, why is it so hard for that to display sometimes? This time it worked. Okay. Now it doesn't work anymore. Can I, now it's not showing anymore. Okay, I can get that menu, but I'm not getting the, okay, now I got both, but I just wanted the top one. How do, Jesus, why is it so inconsistent? It's so frustrating. Like, it's supposed to be Control-Shift-Space. It worked this time, randomly, but like, why is it so inconsistent? This is like my #1 issue with writer. Otherwise, apart from the AI garbage, I like most of writer. Writer seems nice. But just this one inconsistency, it bothers me. I don't know why it's there. Using NVim? No, I'm using writer. Okay, boundary. Okay, now I'm regretting naming this boundary. Boundary edge. There we go. As an alternative. But the NVim isn't an alternative to writer, right? Isn't NVim like a whole different type of beast? That's like saying someone, if someone is not enjoying using Ableton or Reason or FL Studio and you're suggesting them to use like Milky Tracker or some other tracker, it's like kind of a different category almost. Like you make music in both, but they're very different, aren't they? Yeah, the AI like features being everywhere. I've been trying to figure out why it's so widespread. And I'm trying to figure out like, is it because most of my circles are in creative fields? And I'm mostly seeing the opinions of people in creative fields, and the general society just kind of likes AI. Is that the case? Or do nobody pretty much like AI and the big companies are just like over-indexing on the popularity? I don't know which one of these two is happening. I don't know. It's probably a mix of both, but I don't know the ratio. Okay, right, we were gonna do the edge filling, right, and that should not be, that's not a n sides equals 3 case, that's an everything case. No, what? Come on, there we go. Loved your idea of having a soundscape in half edge. It would be so nice. I'm I'm so excited to try that out. I think the average person doesn't care or know about AI. They just use what they think is more convenient, regardless of how it's accomplished. Yeah, I've gotten that impression too. Which sort of makes sense. I think like most people, like normal people, are preoccupied with the daily life. Like if you have kids, you're not going to be thinking about like the long-term impact of AI on society because you're going to be busy like raising kids and like taking care of your family. Like you're way more concerned about like this one teacher at your kid's kindergarten or something where like I don't know, you're not sure if they're actually good at teaching. That like your brain is just elsewhere for good reason. And I think most people just don't have the like luxury to like I don't know, think about deep like implications of new technology or whatever. So like I think there's like a huge part of the population are just very indifferent. And software is just a thing that happens just around them. It's not something that like they spend time on thinking about how to develop or why they get developed the way they are, because like that's just not where their headspace is. But for me, it's very much where my headspace is because I do work in creative fields and I do care quite a lot about the like the impacts all this will have on creative industries. Oh yeah, it is. That's true though. I do think people. I do think parents are probably going to start thinking quite a lot about AI, like when it comes to older kids who are like in school where they might be using AI to cheat on stuff. I think that's when it's kind of gonna come into the everyday conversation, I think. But like it's kind of sad to me to see how quickly AI became normal among random people. Like it would be like completely random stuff where like I don't know, like roll the dice on a person, and it seems like I've gotten an unusually high number of interactions with strangers where suddenly they're using ChatGPT for something. Like it just seems so normal, which I kind of hate. Like there was a meeting in the homeowner association where I live, and they'd been using ChatGPT to like they looked something up during the meeting and they asked ChatGPT about a question, and like I at one point helped someone look for their cat, and they talked about how they use ChatGPT to see like what are the best strategies to find their cat. Like it's like whenever I meet a random person, then I feel like I very often just have ChatGPT just come up casually, and so it's giving me this impression that like it's just become a search engine for most people. And even to some extent to me, like I sometimes use ChatGPT as a search engine. But yeah, it's I don't know, it's just kind of depressing. Especially stuff like, oh my god, like having people defend AI generated music is such a depressing moment. Like when I don't know, I was talking to someone and I was talking about how like it's so frustrating to me that so many of these platforms are just welcoming in AI generated content, which is genuinely displacing real actual art created by people. But then I sometimes get this response where like people are like, yeah, but like this song is actually really good. I kind of like it actually. And like that's the depth of it. Like it just that's not it doesn't go further than that. It's like, "Oh, but it's kind of cool. Like isn't this nice? Like I like this song." And then I think there was like a chart like a really popular AI song. I forget exactly where, but it like topped some chart somewhere. And it's just AI generated music and people like loved it. And then it's just like, "Oh, but that's cool. Like why would you be against cool things existing? How can you be against that, right?" Or people who post AI generated cat pictures or like cat videos or like the one that like gets me the most frustrated is when people post like AI generated like saving pets during disaster. Why am I seeing so much of this? I guess it's like the best like clickbait type of thing of like, here's an AI generated videos of some humans saving the cat and their kittens from the top of a roof during a flood, like that kind of stuff. Why is there so much of this? And it's so depressing that like, I don't know, are people just like so like, are people feeling this massive lack of like empathy and humanity that they're AI generating videos of empathy and humanity happening for lack of feeling that in real world? It's like, man, like what are we doing? This is so it is just so like anti-humanity in every single way. And like, and people are talking about how so many people in society have these like alienation issues. Like, is this gonna help with alienation? That like, well, some of the most human activities of creating art has now been outsourced to AI. That's now displacing actual art created by people. It's like, what the fuck are we doing? Like, why? Why? It just seems like the worst idea possible. But I guess line go up for NVIDIA. Sorry. I have a lot of strong opinions about this, and I shouldn't go on like a huge rant about it. I've actually already made a video about this, so many of you probably know my thoughts on this. Okay. I need to drink some tea. I just slow down a little bit, because I just realized I just got mad. Normally I see these types of videos coming from my parents. Oh yeah, the boomer generation, I think, is extremely susceptible to AI videos. Because I feel like they're the generation that has gotten the least amount of practice and time at recognizing AI generated imagery. And it's real bad on Facebook. I'm gonna tell you right now, it's not great on there. But I guess even on like, I don't know. I guess like it's getting normalized everywhere, so it's probably not just Facebook. And yes, I do use Facebook, but it's just for like cat related stuff. This whole summer, I spent a lot of time helping people look for their lost cats, and Facebook is kind of it's just the local community website where people post about their missing pets. Wait till I get AI people asking to help find AI cats. I think I'm relatively safe and protected from that because I don't think that generates attention. But generating videos of you rescuing a cat from a fire, it's like that gets clicks. So that kind of stuff is gonna, sure, that's gonna happen. Capitalism is where art goes to die or get resold at a higher price. Oh, thank you for the dono. Sort of, but I think the problem is much deeper than capitalism. I think this is like it's more related to like attention economy stuff than capitalism, but it certainly doesn't help for sure. And it's probably like silly stock trading investment shenanigans that leads to a lot of this technology being developed in the first place. Yeah. Yep. I used to think that the hate Will Smith had for the robots in iRobot was unreasonable. I don't think that now. Well, I feel like there was a bit of a time in history where, you know, there was this whole discussion about if a robot had like human consciousness, do we treat it like a human? And then movies usually had this thing of like, oh, they don't treat the robots as humans, but the protagonist is actually going to treat them as humans, and wow, that's so immoral. But that's not where we are now. We don't have AIs that are like human consciousness. That's not what we have. We're in a different situation. So yeah. Okay. I was gonna write some code. What am I doing? Boundary edges. What about boundary edges? We are iterating through them. Assuming we created them. Have we created them? Theoretically, this one would, right? Or no, we need to call insert vertex. Okay. Right. Right. Okay, so this actually comes later. Okay. I guess we can just keep this, but not just populate, but also create them, I think, right? Tetrarch, right, okay. So... yeah. How do I do this? I guess... yeah, what... did I have a utility function for this in the Quadrangulated? So I did have get quad. And I do have all vertices. Where do I do the redirection? Here. And that's in get quad. Do I do all of these at once? I guess I could actually. I guess I could. You know what? We could actually use get quad. That's valid, I think. Or wait, I would have to... create the boundary vertices though. Guess I haven't even worked out that part yet. Can you go over how you jump from the triangle you were playing with to the bevel? Like, how they relate to each other? I think I have a... yeah, so this is a beveled corner. So there were edges going out in each direction here, and now they've been rounded, and then the triangle is the thing that's fitting the hole in the corner of the bevel. So that's the thing we're doing. Have you ever looked at the straight skeletal algorithm? Not in depth. I just know of it, but I haven't used it. Finally found someone else that puts leading and trailing spaces inside of their brackets? Well, it just makes it more readable. Okay. I guess... this is getting a little more complicated now, because I wanted to do like a naive implementation of this, but I don't think I have what it takes yet, because I haven't done the like spline patch decomposition. I guess I could hard code it specifically for n equals 3 for now. I could also just generate the boundary points separately. So I add the boundary here. Do I just add the vertices here already, maybe? But then the problem is that I'm kind of going to do it twice, which is not good. Yeah, the whole problem is that this branching that I do. Okay, hold on. So actually, this whole address thing, I don't need to do any of this if there's no cap. So I think we're just going to special case the n equals 2 case. Why is my keyword wrong? There we go. So if n sides equals 2, then we have single curve join, no cap. So what does fill junction even mean in this case? I guess it's like creating the vertices. That's actually it. I just create the vertices, and then the filling the. I just create these vertices, and then these faces are just going to join everything. So the n equals 2 case is when only this edge and this edge are beveled, but not this edge, which means this one is just going to continue like this, and then it's going to have a single curve like that. Oh, I'm not used to drawing with my mouse. So this one, that's not really a cap. So, and the weird thing with this one is that this one has to share vertices across this boundary. It can't just like create 2 sets or like 1 per boundary. So that's the special case here. Which feels a little gross to just special case that, but what am I gonna do, you know? It's just the way it is. So I suppose in this case we're gonna create the vertices once for one of the sides, and then I think I'm just gonna make the other side reference the same vertices. I think that's the way to do it. So then whatever way I connect them afterwards, they're gonna refer to the same vertices. I think that's the way to do it. Okay, so basically let's see. So we're gonna get what did I call it? Boundary cap boundary? Yeah. Okay, B0 boundary 0, and then B1. Okay. Do I make the populate function? Yeah, that should be in the cap boundary, actually, I think. So it would be populate interior vertices, and then we need subdivision count. And then, oh wait, not in here, in here. Okay, then we got our standard for loop. Did I delete that code? I might have deleted that code. It's over. Okay, so interior vertices means that this vertex already exists and this vertex already exists. So we need to iterate subdiv count. Yeah, subdiv count, but starting from 1. So it's going to be from here, iterating to here. Because subdiv count here is 5. So, yeah. And subdivs, and then I starting from 1, and then insert vertex. We're going to have a position for that. And that's just a matter of evaluating the Bezier curve. So we're going to get t value, which would be I over n subdivs. Let's see. Subdivs is 5. 0, 1, 2, 3, 4, 5. Yeah, it's just over n subdivs as a flip. Okay, and then we need the position from the Bezier curve. So Bezier dot curve dot eval at t, and then that's our vertex. Right, and then it creates the actual vertex in the mesh, and yeah, cool. Okay. Then I should probably do another function to like make it mirror or refer to the other vertices of a different cap boundary. So, you know what? I kind of want these functions now. So if this dot vert t0, or we need to assert that these are equal, so it should be this dot t0 equals other dot t1, or wait, there we go. And then this t1 should equal other t0. That's the only case where we should use this function. And then, yeah. So then I believe all we need to do is, you know what, I'll just clear vertices, and then vertices dot add range other dot vertices dot reverse. reversed. What's the... Excuse me? Is add range not enumerable? Yeah? What? Am I stupid? Oh, wait. Hold on. Hurt. What? What? Shouldn't this return an enumerable? Void is not assignable. Is that because vertices is a list? But I need to like cast it to like... It's enumerable? Because reverse is an instance function, I guess. Is this the way to do it? Oh my god, operator precedence is murdering me right now. Okay. Okay. Cool. Yeah, reverse is an in-place method for lists, but there's an extension method for enumerables that's called the same thing. That's not an in-place reverse. What should this be called? This would be populate vertices reversed from. There we go. Cool. Right, so now we're back to the actual code. So if n sides equals 2, we are going to do b0 dot populate interior vertices and subdivs, and then b1. I guess I can just do binder 1, populate vertices reversed from b0. No cap. Okay, is that it? I think that might be the single curve, because we got the Bezier already, so that's established. Yeah, this should work. This should work for n equals 2. Cool. So then we got the more complicated one. So do I hard code for n equals 3, or how do I do this? Because previously I used the barycentric coordinates, and I was getting the coordinates off of a cubic triangular Bezier patch, and I could get the coordinates in 2D, but I don't have patches that matches any number of sides. So how is this gonna work out? Yeah, I'm gonna need to add another layer of like going from... Yeah, there's like two things I would need to add to this. Where are we at? We're at the combination Pizza Hut and Taco Bell. So like... The thing I have, the thing we've been working on, that's a generalized n-gon, is a 2D coordinate for stuff like, you know, oh, here's a pentagon, and we have all the coordinates that we want for hold Wait, I forget where the line goes. Doesn't matter. We have all the 2D coordinates for all of this. Wait. No, it doesn't connect to the vertices. There we go. Okay, got confused there for a bit, but I'm okay. Now I got it right. This looks close to what I have. So like we have these 2D coordinates. But this is in 2D. This is not in 3D. And so the question is, how do I get a spline patch that can translate from this 2D coordinate into a position on a spline patch? This is where we get into the stuff around generalized barycentric coordinates, and that is a whole mess. That's like a whole wonky thing, and I don't have any kind of like support for generalized. I guess they'd be called a PN patches. So like I have the 2D coordinates, but then once we're in 3D, and this represents a very strange bevel that has, you know, 5 edges going into it. Getting those points is tricky, but I'm thinking I'm going to subdivide this into square or triangle patches depending on the shape. Actually, would it always be possible to do square? I guess it would. I guess I can use square patches for this. So like, I'm thinking I'm gonna have to like divide this up into square bilinear patches. So we would have like one spline patch here, another spline patch here, and so forth. I don't know how to draw anymore. It's over. Like drawing a line and then ending it at a specific location, that's like advanced drawing. That's like really, really, really difficult. Like ending it at the other line, like whew, not easy, not easy. So if I can convert it, or rather if I can set up these spline patches, which should be very easy actually. I think, wait, hold on. Or no, yeah, I think it should work. Drawing circles is not easy. I feel like I've gotten better at it of late. Maybe I'm not. Okay, yeah, no, I don't know. This one's pretty okay. Look at this. We're ready to talk about trigonometry. I guess the trickier part is kind of the figuring out the center vertex here, actually. But that could probably be could probably make an educated guess, but... Can you split it into convex and concave polygons? I don't think... Or that... I don't need to? So... I'm not sure what I would use there. Concave feels like it would be significantly easier as a starting point. I'm not sure what you mean by concave. But yeah, I think this form is... It's nice in the sense that converting from 2D coordinates to the coordinates of each spline patch is like trivially easy. It's literally like, it's just an inverse bilinear, right? Because I sort of already have the internal coordinate system is sort of already forming a basis here. So then I just need to get the corners, each corner here, and then inverse bilinear, and then we're cooking. Then we're ready to use it in a spline, or in a spline patch, I guess. Sum of angles being more or less than 360 degrees. I'm still not sure what you mean. What's inverse bilinear? Yeah. So bilinear interpolation is when you have a set of points. Like let's just pick a set of points. And then these form a little shape. If you want to be fancy about it, you can call it the convex hull. And so if you want to get a point in this coordinate system, you can sort of think of it as like, if you take the halfway point here, connect it to the halfway point here, like this, you sort of have this coordinate space, right? Kind of like this. It looks 3D, but pretend it's not 3D. That's just kind of an illusion. So then let's say you want to get a position inside of this quad. Then you would generally have a coordinate system. So you would have an x-axis and a y-axis along this whole thing. So this corner would basically be 0, 0. This corner would be 1, 0. So it's like a 2D coordinate. And this corner would be 0, 1. And then this corner would finally be 1, 1. So usually when you have coordinates like this, that's like a 2D coordinate along a surface. You would call this like the u coordinates or the u direction, and then the v direction or the v coordinate. So together you would call this a uv, and that's where the term uv comes from for UV mapping, if you're familiar with that in 3D modeling. So we kind of have this like two-dimensional coordinate, right? And the way to, if you then want to go from a UV coordinate, so like, let's say you have a coordinate, u, v, you have a function, let's just call it f, a function where you pass in the u and v coordinates, and then out of that you get another coordinate that's in that's in whatever space this is interpolating in. So let's say you have, maybe these are vertices of a mesh, and maybe they are 3D positions. So basically what you do is you take the data you have in each corner, and then you blend them in a bilinear way. So this could be stuff like maybe the thing we're interpolating is color. So maybe we have colors for each of these corners, or associated with each of these corners. And then we basically want to figure out what color is at a specific UV coordinate. So maybe we have a coordinate that's like, I don't know, on U, maybe we have like 0.6, or like we're passing in 0.6 in this function. So let's see. So we have our function, we're passing in 0.6 and V coordinate of 0.1. And then we're like, okay, what happens, or what do we get? What's the color we get at this coordinate? So we could then say, okay, so 0.6 is a little after halfway on the U-axis. So on the U-axis, we're kind of on this line somewhere. So we can kind of take we can then linearly blend these two colors with the weights of 0.6. So we're basically doing a lerp between blue and green. And so we have blue, we have green, and we want to blend between those two colors. This was a very, well, sample the wrong color. This is a bad example, but wow, look at that. Now we have a blend. So this is a linear blend between those two colors. And we want the color at 0.6 along this gradient. So 60% from start to finish. So 0.6 is not halfway, it's somewhere here, right? So then we're like, okay, so that's the color that's here. So that's a color that's a blend between these 2 points along that line. And then we basically do the same thing here for these 2 points. So we're gonna get some kind of gradient with these colors, ideally, hopefully, like that. And then we basically do the same thing here. We have our coordinate of 0.6. We're going to get 60% into this color gradient. So 0.5 is there, 0.6 is somewhere there. So the color that's on this edge right here is this color right here. And then, so now we have the colors on the boundary here, but then we have the other coordinate. So we did 0.6 now for these two gradients, but then we have 0.1. So 0.1 is going to be the t value, or the percentage we want to blend between these two colors. So we need to do the same thing there for those two colors. So we grab the bottom color, and then we grab the top color, create some kind of gradient. There we go. And then we want to sample at 10% into this gradient. So that would be like somewhere here. So we would get that color, and I didn't really make this gradient very, very good, but pretend I sample at 10%. So like it would sample here or something. And so we would then get this color, right? So this is called bilinear interpolation. And it's called that because we're kind of doing linear interpolation in two different directions, and bi just means two. So that's where the bilinear comes from. We have a linear axis here that we're blending in, or rather we have a linear axis we're blending in here, and then we're linearly blending in the other direction. Bilinear stuff is nice because there's a lot of properties that are kind of preserved under transformation, meaning we can like transform this whole plane and everything works out nicely and everything is just the way you would expect it to be. And there's a similar thing for triangles that's called barycentric interpolation, which is a little bit more complicated, but it's a similar idea. Okay, so this is bilinear interpolation. Okay, so let's say this gave us this color, right? This is a standard bilinear interpolation function. We have a coordinate in this two-dimensional space, and out of it we get whatever data we want to interpolate. In this case, we interpolated colors. Okay, so that's what bilinear interpolation is. But you didn't ask, what is bilinear interpolation? You asked, what is inverse bilinear interpolation? And inverse bilinear interpolation is basically the opposite. So the inverse function to this is given some color, what are the UV coordinates for this? What's U and what's V? So this is the inverse function. So it's inverse bilinear interpolation. And this is more complicated, depending on your data, but generally it's more complicated. Because now we're starting out with some kind of data point, and then we need to figure out what UV coordinates lead to that data. And in some cases, that's not even possible. Like, I don't even know if purple exists within this space. It's probably like, it would have to extrapolate like these two or something. Because between these, it's going to be kind of a bland, muddied version of both of them. So it's probably better to pick some other color, like the one we already know the coordinates of. So yeah, the inverse function would give us the coordinates back. So in this case, it was 0.6 and 0.1. So that's inverse bilinear interpolation. Okay, in my actual use case, we're basically doing the same thing, but between two different 2D coordinates. So this is kind of like a space transformation, but with some distortion as well. So we have a coordinate system defined by these four corners. That's our bilinear corners, right? So 0, 0 would be here, 1, 0, 1, 1, 0, 1 for each of these corners. And yeah, and so we're basically gonna go from a world space axis where, you know, we have X here, we have Y here, from a world space coordinates to the UV coordinates. That's what we're gonna do. That's what I want to use bilinear interpolation for. Yeah, that's what that is. And the reason we need this is because the like solver that I made to find like the nice tessellation is working in the 2D coordinate space that's not this coordinate space. It's working with world space coordinates. So 0 is in the middle here, and we have the x-axis going to the right, and the y-axis going up, and the like circumcircle of this shape. That's where the magnitude is 1, right? Because this is in the unit circle. Perfect circle, very good. And this is notably not the same coordinate system as this, right? So basically it's converting between those two. And because it's not a rigid transformation, as in, you know, we don't have 90 degrees in the 2D coordinate system, or the world space coordinate system is not 90 degrees around every corner here, means that it's not a simple transformation. It's not just a matter of like moving it and scaling it or whatever. Like, I think it's called an affine transformation or something. This is more akin to like a perspective projection. Yeah, and so bilinear interpolation is, or like inverse bilinear usually involves a root solve, because that's just how the math works out. But yeah, that's what I need to do in order to get a local coordinate within a spline patch. So I need to go from the 2D space coordinate to a local coordinate in a spline patch, and then the spline patch takes us to the 3D coordinate in 3D space. I'm not exactly sure how to draw a bevel with more than 3 intersections, because that's kind of what this is, but yeah. So there you go. That's inverse barycentric interpolation. Or no, inverse bilinear. Barycentric is very similar, but it's a triangle instead of a quad, and you have 3 numbers instead of 2 numbers, and I think I talked about it some streams before. But yeah, let me just move that a little bit. Just to make this a little more complete. There we go. These aren't arrows. I feel like it should be an arrow. Oh, someone asked if I draw notes like this for myself as well, or just when explaining stuff. And I drew this line at 0.25. Like exactly. Oh well. And yes, I do draw notes like this even if I'm not explaining to other people, because I very often need to explain stuff to myself, and drawing just helps a lot in getting a good sense of the problem that I'm actually solving. Because I don't know, sometimes you have a lot of stuff to keep track of, like, oh, if I'm extruding faces, I need to like consider what to do with the elements that I have in place, or how do I define edge loops, and like how do I, like, should the boundaries affect stuff, and like just drawing this helps so much in yeah, in actually knowing what you're doing. Like even this stuff is like, this is like a really simple thing, which is just like, what do I do when I delete a vertex? Like it seems very simple, but it's relatively complicated because you need to redirect all the elements correctly. Yeah, and so it's always good to draw, because then you know what you're doing. Or you're gonna know that you don't know what you're doing. That's what drawing helps you realize as well. And knowing that you don't know what you're doing is better than not knowing that you don't know what you're doing. So we need a function of inverse 2D bilinear. No, we just need inverse bilinear. Because we're going from a 2D space to a 2D space, which is, yeah, it's kind of multiple transformations in one, or like happening one after another. So first we have a 2D space where you have the pentagon. So this is a 2D space, x-axis, y-axis, and then we're going to transform that to the spline patch, which is a different 2D space. So that's going to be x and y. So 0 is here for this space. 0 is here for this space. And you have like, this is 1, 0. And this is 0, 1. But here, this point is 1, 1. This point over here is 1, 0. This point over here is 0, 1. Okay, they kind of look like periods. It should be comma. And 0, 0 is there. So this is going to require inverse bilinear. When jumping to that coordinate space. That does not involve any Béziers at all. But then, once we've gotten those coordinates, we are going to go to the 3D space. And so in the 3D space, I don't even know what shape it's going to be. It depends on the bevel, I suppose. There we go. That's a wonky little shape. So this is then going to be transformed by a cubic Bezier patch into 3D space for whatever vertex we want to do that transformation with. Or maybe not even vertices, could be any location on this. And this would just give us a position in 3D space. So, you know, the axes would be whatever the origin of the mesh is. So we're going from 2D but wrong, and then 2D but correct, and then from 2D to cubic Bezier patch, transforming it into 3D space. That's the whole process. But it's getting really late, so I think I'm gonna be calling it a day today. So we're gonna do this next stream. But I have a pretty clear picture in mind for how to do this. The only thing I am not 100% sure of is where to put this vertex in 3D space. That's the thing I am not entirely sure of yet. Because it's not the original vertex when you're beveling that corner. Because that one is way too far out. It kind of would be that corner if we were using B-splines, but we're not using B-splines, we're using Béziers. Yeah. So first transformation could not be achieved via matrix because it's not affine. I think that's the case, yeah. I think you could probably do it with a perspective projection. I would guess that, like, you can probably solve this using a matrix, and it would probably involve, like, I don't know, the determinant of a bunch of coordinates, and then you would get some kind of projection matrix out of that. But I'm not entirely sure how to do that. So I'm probably just going to do inverse bilinear. And it's going to work. So, yeah. Yeah, I'm still trying to work out what the central vertex would be. I'll probably figure something out. It'll be fine. I think there's like a lot of solutions for it. It's just a matter of like trying to figure out which one is best. I'm planning on doing different bevel shapes or just rounded. Right now, just rounded. Well, I mean, if you set the subdivision count to 1, it's going to be flat. So, because that's just rounded with one segment. You could also try linear interpolate on volume textures. Yes, you can. So bilinear interpolation, like this is what, like, GPUs generally do this with shaders when sampling textures, because like a texture is really just a bunch of colors, right? It's a texel here, you have a texel here, you have a texel here, and you have a texel here. So this is like a 2x2 texture, right? And so when you're sampling with bilinear interpolation, you're gonna see this like smudgy blur between these four colors, right? So that's what textures look like when you're rendering it with bilinear interpolation on the GPU. So if you're, but you can usually, like in Unity, you can configure textures to use point sampling, and then it's not going to do bilinear interpolation. So then you're going to have these like sharp borders between the pixels, but that usually leads to anti-aliasing issues. So if you want to have anti-aliased sampling of that, that's going to be like a whole other step. But anyway, any other questions before I head off? Oh, I went like full screen mode on this. Can I not do full screen mode? Oh, there we go. Too easy to have an invalid projection plane? Would it be invalid in this case? Or I guess maybe if it's like actually not, like I don't know what the math would look like if you were to, because like if it's actually like an orthographic situation with the perspective like divide by 0 or something, I don't know. Can I get that Photoshop file? I sometimes upload some of, well, I think I've done it once actually. I shouldn't say sometimes. I have uploaded some of my sketches on Patreon. So if you want some of those, they're on Patreon. I have considered doing that more often. I'm just really bad. I'm really bad at supporting my Patreon supporters. But they are very good at supporting me, and I appreciate them lots. But if patreon.com/acegikma, there we go. Did I spell it right? And can I send this here? I'm using the OBS to send this. Can I do this? Does this work? There we go. You can go to my Patreon if you want to support my work. And one of the posters that I've done, I think that the one that I have on Patreon, I think is from one of my math classes. Yeah, so I think that one is on Patreon. If you want that, yeah. Okay, so there's my Patreon. There's also, I also have a Discord server. It's linked in my YouTube profile page. Channel, if you're curious about the joining my Discord. I've also got a website for Half Edge that I'm currently typing. I'm very good at typing. I have a website for Half Edge, so there's also a Discord for Half Edge if you want to join that. Yeah, feel free to check it out. I've also got a list of planned features of what Half Edge is supposed to be for 1.0. There's a lot of features that Half Edge is not going to have for the initial release, just because I need to make sure that I don't spend too much time on things that are going to take too much time. Yeah. Okay, hold on. I feel like I missed a few questions. Isn't there an equation to get the limit position of applied infinite subdivision under certain subdivision mode? Yeah, that's a B-spline. Or like the Catmull-Clark does approach the B-spline. Oh, you're thinking I could use the subdivision to get that corner vertex? That might actually be true. It feels a little cursed to use a recursive method to do that though, because I think you can directly get that one. But yeah, that's probably true. Okay. All right. I successfully used OBS's interact with browser feature. What is the motivation to start streaming development? I was curious to go back and trying to do it again. But I've done it before. This isn't my first time streaming development. I did it on Twitch for a long time. But I also wanted to try doing it on YouTube just to see if there's any difference in terms of like engagement, chat, or like revenue or whatever, because like Twitch didn't make me much money at all, and so it just felt not very worth it to stream. And also like, this is gonna sound weird, but like ever since I started medicating my ADHD, I kind of just didn't want to stream anymore. I just didn't feel like streaming for like a year or two, something like that. I don't even remember how long ago it was. And so I just kind of stopped streaming for a while. But then I wanted to try streaming on YouTube just now for a bit to see how it works out. And it would be cool if that actually generates some amount of income, because then I have an incentive to do it. But beyond just wanting it myself. Streams have been fun. I hope you keep it up. Yeah, we'll see. Can't promise anything. What's the Handmade Network? It's basically a community, like an online community of people who, mostly it's people who care a lot about low-level programming. But in a more broad sense, it's like people who care about making good software and not just pooping out slop. And so it was kind of it's a neat little community. So I spent some time there. They also had a conference for a bit that I talked at. What's the income Twitch versus YouTube so far? It's kind of hard to tell because it hasn't been a month yet of me streaming on YouTube, so I'm also very forgetful, so I don't remember what I had on Twitch. So I don't know it from the top of my head. It wasn't a lot. It was not enough for me to think about it very much. It wasn't nothing, but live dev is very cool, thank you. I'm glad you appreciate it. I've also noticed that like it's pretty, like I used to get a really, really, really bad headache when I streamed. That's also part of the reason why I stopped streaming. And I think it might be because of like, I think it's probably like a lot of mental overhead to both be on camera, reading chat, responding to questions, and then also trying to solve like the actual programming thing that I'm working on at the same time. I think it's just a lot. That's a lot that's going on at the same time, and I think it's easy to like not notice that it's taxing to do all of these things at once. Because it would be a lot easier if I could just remove some of the complexity of all of that. Like, I don't know, if I was supposed to just be educational and talk about stuff, that would be easier. But if I'm also trying to get work done, you have to juggle a lot of stuff. But anyway. All right. Well, thank you all for joining. I don't know when the next stream's gonna be, because I don't want to make any promises for burnout reasons. So we'll see. I'm gonna try to just stream more often this month, or like for a month, just to see what would happen. Because like if YouTube if YouTube somehow makes orders of magnitude more money than Twitch did, I could like I could like actually do this a lot more. So, because now I kind of do need to freelance every now and then just to make sure that I get by. And it would be nice to not have to do that. Especially because I think because I stopped streaming for a long time, my Patreon has just been going down. And also because of like general inflation reasons, like if someone is on my Patreon for $1, like $1 is not worth the same as it was back when I started my Patreon. So like, I don't know, there's a lot of things are going down financially for me, and so I need to make sure I don't go into the negatives, because that would not be good, because I have a lot of cats to feed, you know? Sorry if it's off topic or personal. Is it really comfortable to have glasses so low? Asking them because I use glasses and I feel really uncomfortable when they get lower. They're kind of right on the boundary where if... Actually, they're really low now, yeah. But no, I feel like it's fine. It's not uncomfortable. It's not uncomfortable for me, because then, well, then I wouldn't do it. I think like as soon as they start poking at the, like, these, I don't know what they're called, nostril exteriors. Like as soon as I do that, it's like, that's when it starts feeling uncomfortable for me. So they're like right on the edge there. Yeah. But no, it's not uncomfortable. And this is like, I have my monitor really low. Like, this is the direction of my monitor. So like, I'm pointing to the top of my monitor right here. And so the top boundary of my glasses is above my monitor. So I'm like seeing the monitor perfectly. So yeah, I'm just used to having them there. I don't know. It's just where they are. I guess the camera is also up, and that makes them look like they're sitting like super low. But they're not like super low, I think. I don't know. I'm also probably like hunched over like a hermit. Met you on Twitter, and you doing both code and art gave me not just inspiration, my philosophy. Oh, that's nice. I'm not on Twitter anymore. I'm on Blue Sky these days, because Twitter kind of turned into a Nazi AI hellhole. But these days I'm on Blue Sky. I guess I'm so bad at promoting my stuff. There you go. Here's my Blue Sky. If you're using Blue Sky, that's my profile. My kids, in other words, my cats, are also on Blue Sky. If you want to follow Toast, Salad, or Thor, they're all there. If you want some non-AI generated cat pictures. Alright. Okay, I gotta get some more to eat. And then I'm probably gonna play some more Silk Song, actually. Just a little bit before going to bed. Is that Twitter but good? Pretty much, yeah. It's one of the Twitter likes. I feel like there was a question I missed. It just popped up in my head. Did it just disappear? Why did I even remember it? Was there some question that was like almost related to something I mentioned? What tablet? It's a Wacom Intuos. No. Yes? Intuos something. Medium. Some kind of tablet. I don't know the generation. I'm bad at this. Intuos Pro. Yeah. Medium, I think. It's a tablet without a display, so a regular standard tablet. I have a question. Is teal, magenta, and purple a viable 3-color palette for 3D space? I mean, there's a ton of 3-color palettes for 3D space. That's like the whole... if you want to get into that, you can look at... If you search for color primaries, those are kind of like the corners that define color spaces, and then usually things are interpolated between those. But I'm sure there's some color primaries that, well, I mean, subtractive rendering or like color spaces for print, like CMYK is pretty much that. But I guess that's 4D space instead of 3D space. Blue Sky's Democrat Twitter? Sort of, yeah. Yeah, I wish a lot more people used Blue Sky who are still on Twitter. I pulled the trigger and I did it. I left Twitter even though I had a really big audience there, and feels kind of sad because I don't know. It sucks to like lose out on an audience, especially when you built a good audience somewhere. But I legitimately just felt unhappy being on that platform after a while. It was just the feed was just full of garbage, and I got so many replies where I didn't even know if it was people or if it was just bots. I don't know. It was just starting to get miserable. It was getting in the way more than it was helping, so. Okay. Thank you all so much for joining. I hope this was interesting, or a good background noise, or like a co-working vibe, or I don't know, whatever this is. I don't even know what this is apart from yapping into the void and trying to get some work done. You asked a question about my half-edge link? Oh no. I don't know where that is. How many years ago did you start programming? When did I do that? I mean, I did some like very, very minor stuff as a kid. Like noodling around changing variables in JavaScript. Like, but then I got into it properly in 2010, I think. Around then is when I found Unity. And then that's when I started doing C#. Yeah. Yeah, I think around 2010 is when I like properly started programming. Yeah. All right. Anyway, thanks for joining, everybody. I will see you next stream, whenever that's gonna be. So I'll see you then. Thanks for joining.